Hello, 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 ladies, gentlemen, cyborgs, good morning, good afternoon, good evening. I should really learn to start ducking my music. Welcome to the show, and I've got two faces again. Don't you hate it? Anyways, thank you so much for allowing me to take a day off. It was truly, well, I mean, I didn't really spend it taking the day off. I was working on the 3D printer. But this thing is turning out to be one heck of a heckin' printer here. This thing is crazy. Let me, I just realized I never plugged in my thing. All right, let's schmooze for a little bit as I get caught up on the chores that I should have done last night. So the project continues to be the E3D Toolchanger. E3D Toolchanger is a pretty kick-butt printer that has a, well, I'll show you in just a sec. How's everyone doing, by the way? Am I coming through loud and clear? I'm not seeing anything show up in chat. And I don't know if that's my problem or if that's your problem. And I just realized I can't plug this thing in. Because this USB cable is too small. Alright. Where is it? Oh, it must be... There we go, that's it. Alright. So, today we're working on... Oh, there it is. Yes, I got my Aloha shirt because it is hotter than heck out here in Colorado, but the air conditioner got fixed, so no more flickering. Yeah. Wait, that's not what's supposed to happen at all. There we go. Okay, good. Just making sure everything's working. Alrighty. Here is the E3D Toolchanger. This is our Toolchanger motion system. Who knows? So this week I have been working on this thing a lot. And I know you're gonna have to forgive me if you feel shortchanged. Am I being quite? Hang on a sec. Let's turn up the volume a little bit. How am I doing? Am I still quite? Awesome. Yeah. So let me realign my chi. Let me center my mojo. Behold the Toolchanger. So this past week, I've been doing a lot of the really nitty-gritty assembly, and I'm sorry if you feel a little shortchanged, but let's put it this way: if I had put all this on stream, you guys would have been bored senseless. There was so much backtracking, reworking, reprinting, modeling, all kinds of dumb crap that I had to do over and over again. I'll give you the tour in a brief second, but we have two orders of business before we do so. First, oh, that's not what we want at all. First, as is tradition, we must turn on the shelves. So let me log into my shelves and let's switch them on. There, come on. Yeah, there we go. The ESP82, and you can see that I've also labeled all of my bins. Here, let me turn this a little bit so you can see my personal favorite. It says, "Why are we here and what is our purpose?" It's hotter than heck. Now I actually know what's in all these bins, and we'll spend less time hunting for parts and more time building stuff. So, next order of business is, why isn't this camera working? I just can't catch a break. Why are you doing this to me? To err, you know what they say, right? To err is human, to truly mess up, you need a computer. All right, excellente. And final check. Got Toolchanger in frame, in view, ready to go. So let me explain. All right, so second order of business here. Before we get too deep into this, we got to talk about this right there. Today's stream is sponsored by Things.com. Things has been super good to the channel. They've been helping us out a lot. And we're honored that they felt like sponsoring another stream. Whether you are looking to share your projects online or find a new one, use the link in the description to go to things.com. Take a look around. The site's super fast, it's super responsive. They've made a ton of quality of life improvements, especially for project creators. So if you haven't uploaded a project there in a while, you should totally check it out because they give you a lot more options to make life so much easier. So yeah, whatever things you're looking for, get them on things.com. Now, today we might even upload some of our own files to Things because I actually had to do some design for this, like a not insignificant amount of design either. So yeah, so here, take a look. This is the E3D motion system. I'm going to turn this way so I stay in frame while I'm gesticulating. Yeah. So this is the E3D motion system, and this part here is the Toolchanger. So these are the extruders that we were working on before, and I've got them all wired up. See, this one's got some extra stuff in it. We'll get to that in a sec. So this guy moves back and forth and picks these up and engages them. So I am going to now, let's see, on my other monitor, I'm now going to log into the printer. It's got Wi-Fi, so I should be able to log in. Very nice. This is using, by the way, it's using the Duet board. It's using a Duet 2 and Duex. So any of you are familiar with building RepRap type printers from scratch are familiar with what I'm looking at right now. For all intents and purposes, so I thought this would have some really complicated like science under the hood to get the Toolchanger part to work, but it turns out that this is actually a feature that's been built into G-code forever. Remember, G-code was designed for CNC machines, right? It was designed for automated mills, and it's normal for mills to change their tools. Automated tool changers and CNC mills are nothing crazy. If you have ever had a circuit board made, right? If you ever had your own circuit board fabbed, then you've had a piece of work made with a tool changing CNC machine. This uses the same G code. It just implements it differently in firmware. So let's home this thing. You can see it's homing the tool changer. It's homing the C axis. Look at the gears are going to turn in a sec. There they are. And then it's going to home X and Y. So today's orders of business are, well, you can see right there. Oh, it still thinks it has a tool attached to it. We're gonna get rid of that. There we go. So you get the idea. So we still need a bunch of work. There's still some horseplay and shenanigans going on here. There's still some stuff that needs some misaligned. It is very quiet, which is really surprising. So before I get off topic, let's take a look at the tool changing. All right, so check this out. So the tools they go 0 to 3. They start at 0 because we're nerds, and nerds never start counting at 1. So let's pick up tool number 3, and let's hope it doesn't go crashing into oblivion. Come on, you can do it. You can do it. Oh, there it is. Check that out. Let's swap over to tool number 2. Don't die, don't die. Oh, it's looking good. It's looking good. All right. Let's pick up tool number 0. 1 is the one that I'm still worried because this thing has misfired and dropped tools a whole bunch of times. Come on, you can do it. Oh, and it's the connection is rock solid. It's rock solid. Look at this. It's only moving because I'm putting my whole weight on it. Yes, Rene, the gears are free. I've been trying to dial in the right tension so that this little guy here is spring loaded. Let's move this over so you can actually see. So yeah, this part is spring loaded, and I've had a bit of a time dialing in the right tension. Too high a tension, and it won't be able to engage the tool plate. too low of a tension, and it will just allow the tool to fall off as soon as it's done. So yeah, that's the E3D Toolchanger. Now this tool here that it's got picked up right now is where we're going to start working today, because this is the water-cooled tool. Now, alright, yeah, this one is the water-cooled tool. Now, I had hoped that I'd be able to do this without having to rearrange any cameras, but it doesn't look like that. There's going to be a lot of camera moving around today, so, you know, if you're queasy, pardon, this may not be the stream for you. The Toolchanger part is really sick. Let's dock this. let's dock this guy, and I'll show you what's going on here. Please don't pull it off. Oh. Alright, so there's still a bit of work to do, but on the whole, the Toolchanger part's working pretty well. This is running on RepRap firmware. Gigawatt asks, is this running on Marlin? This is running on RepRap firmware, but it's Marlin. I think it's in Marlin compatibility mode, if I'm right. Yeah. Anyways, liquid cooling part. Okay. So there are a whole bunch of things to do today, and which ones we do depends on a lot of factors outside our control. The first one, the one that we know we're going to do, is we gotta deal with the liquid cooling loop. So, yeah, there is a nice reflection. Rene points out the reflection of the chromance on the print bed. If that's being too annoying, I will cover it up with a sheet of paper or something. Yeah. So, the liquid cooling serves a really interesting purpose. So in a PC, liquid cooling serves to kind of like allow basically like to allow a part to be cooled with more cooling than you could fit on it, right? Instead of having to get one fan on your CPU or 3 tiny fans on your GPU, you can instead route that heat over to a larger radiator and use like 5 slow fans. On a 3D printer, it serves a different purpose. See, this is going to be a fully enclosed 3D printer. And a problem with an enclosed printer, well, I mean, the reason you use an enclosed printer is because the chamber, right, is enclosed. It heats up. The heat's trapped inside, and it warms up. The problem with this is that the air inside the printer is warm, so fans won't have anything to blow, right? You know how on most. Here, let me switch back to here so I can show you what's up. So usually most extruders. I'm actually going to grab tool number 2 here because that's easier to show. So yeah, you notice that this thing has 2 fans. It's got one that cools the motor and the filament path, right? It's got another that cools the part. Now, if the chamber is heated, neither of those are going to come into play, right? Because the fans aren't moving cold air; they're moving hot air, right? So for the part cooling fan, that's whatever. Like you just don't get a part cooling fan you don't want a part cooling fan if you're printing something enclosed, right? You're printing it enclosed because cold air will cause it to warp. So you don't want the part cooling fan at all. But the hot end the motor and heat break cooling fan, that's a problem because steppers will overheat, and if the filament path gets too hot, the filament will melt prematurely. It'll melt before it gets itself into the nozzle. This is a huge problem because generally if you're printing something in an enclosure, it's printing hot. Like we're talking scraping the upper edge of what you can do on something like a Prusa or whatnot. So that's the purpose of the liquid cooling. Is it drags the heat in a fully enclosed thing. It pulls the heat off the motor and off the filament path, and it takes it out of the printer, out of the enclosure, where fresh, cool air can cool it off. That's the purpose of the liquid cooling. So it's not so much increase. It doesn't so much increase performance. It doesn't increase performance so much as it enables a feature that doesn't really work normally. So this is going to be important. It's going to be important, especially for filaments. It's going to be important for 2 things. The first is filaments in which the glass transition temperature is much lower than the radiator is outside. This is the outside of the printer. That's what Gigawatt says. Gigawatt says, why don't you just put a radiator outside? It is. It's right there. I'm getting a little My ADHD has been very, very strong with this project. Yeah. So, this thing, yeah, there are two kinds of filament that this means a lot for. The first is filament that has a glass transition temperature far below the temperature that you want it to print at. PLA is the most notorious. PLA prints at a very low temperature, especially relative to what it melts at. The glass transition temperature is around 50, 60 Celsius, but you can print it at like 210. Yeah, so normally you can't print it in an enclosure because it'll melt prematurely. But now you can. The second thing this matters for is filaments that print at a very high temperature. If we're, for instance, PEI, yes, the stuff that the bed is made of. You notice this is a glass bed. This isn't PEI, and that's intentional. It's intentional. We are going to be printing in PEI for the Every Filament episode. That prints at 400 Celsius, and that is more than hot enough to damage. Basically, it'll melt the enamel off the motor wires if it's left unchecked. So for both those situations, that's where the water cooling is at its finest. So I think we've talked enough about this. Let's quickly run through what we're going to do today. The first thing we need to do is we have to wire up the radiator and the pump. This should have been done already, except I made a few boo-boos. I kind of forgot that the radiator and pump are 12 volts, but the control board and all the fans and stuff are 24 volts. Yeah, so I blew out a fan and I burned out a fuse, so we got to replace the fuse. I already replaced the fan, but the pump, alright, you can't see what the hell I'm pointing at. Okay, but the pump, right, we've got to wire this pump up to a DC-DC converter. And then we have to wire both those in, throw a new fuse, and just make sure those work. It's Rene says my newest tutorial is about mounting a 12-volt PSU in the Toolchanger. I can see that. I'd hope that the PSU would have two rails, but it does not. It's not a big deal. I went to Micro Center yesterday, and we got a whole bunch of these DC regulators. These buck converter modules. Focus, please. Yeah, we got a whole bunch of these buck converter modules, and before we get too deep into the weeds here, we'll set this thing to 12 volts. These are also nice because we can use them to adjust the like how fast the pump and stuff is going. For now, we're going to wire this up to the always-on outputs. It's a little tricky. I think it'll be. So we only have one. All right. So here's the situation. This thing has a billion fans in it, right? It's got each of these has 2 fans. So this thing has 6 fans wired up, and that uses up almost. So it's got 6 fans wired up, and actually, now I'm thinking about it. Hang on a second. I made a mistake. We actually do have them. Matt Guard asks, is this going to have enough amps? It should. These both take. This one can take up to 500, either 500-600 milliamps, and this is about an amp. But that's at 12 volts. This is at 24 volts. So, and buck regulators like this tend to be in the neighborhood of. They're going to be in the neighborhood of like 95% efficient. So for all intents and purposes, this is going to have the amount of current that these guys are drawing. So it should be able to. The fuse is set to the fuse that RepRap installed was only 1 amp, and I think that seems a little low. I don't know why they did that. So I'm thinking of replacing that with a 2 amp fuse. But that should be enough, even though there are a whole bunch of fans and stuff. Most of them aren't going to be on. Like only 2 of them are ever going to be on at once. Because we don't need to cool. I don't think we really need to cool hot ends we're not using. So without further ado, let's turn our attention towards the workbench. I'm going to completely fail to move my chair over and run over everything. We're going to do just a quick bit of. We're just going to wire this up, get the voltage right, turn this around. We're going to wire it up, we're going to get our voltage right, And then we're just going to solder in a connector. We're going to solder in a pair of connectors so that we can wire this thing up. Very, very nice. Alright. Okay, let's switch this over. How are we doing here? We're looking good. Alright, so we actually have a number of things to do today. First thing is, we're gonna wire up the radiator and pump. That's what we got here. Let's grab our soldering iron. Actually, I'm gonna move this over a little bit. There we go, perfect. So we're gonna wire up a radiator and pump. The second thing we're gonna do is, once we have that wired up, oh, the mic is far too close. The mic is far too close for me where I am right now, so let's put that over here. Alright, we'll move that later. Okay, second thing is, once we have that wired up, we will we're gonna purge the cooling loop. Basically, oh crap, I'm supposed to get more distilled water. Oh man, I made a minor boo-boo. The cleaner I bought is only supposed to be used on copper systems, and this is an aluminum system. So, yeah, we'll just mix up a partial batch. So basically, we're gonna use some. Oh wait, what am I saying? I have tons of distilled water. Basically, we're gonna use distilled water to just give the loop a good cleaning, and hopefully it doesn't leak. If it leaks, then we'll have a problem. That'll probably be one of those streamer moments. Let's adjust this so it stops trying to focus. They'll have one of those streamer moments. Yeah, and then we'll basically we'll get that circulating. We want that to circulate for a bit before we let's turn off our focus. I had all this set, and then I had to restart the computer. Yeah, so I'm losing my train of thought like crazy here. Basically, we want to circulate the distilled water for a while to clean out the system. And while that's running, then we'll heat up and basically tighten up the nozzles in the system. That has to be done while it's hot. I want to make a minor change. We installed a regulator Volcano, We installed a regular Volcano block on one of the extruders. I want to replace that with a high temperature Volcano block, and we're going to use a nozzle X. Basically, the aluminum block can actually melt at the temperatures we're going to be printing at. So, yeah, all kinds of fun stuff. So let's see. Oh, I have something to pick up. Excellent. So first thing to do is let's just connect this up and dial this in to 12 volts. And that's really simple. So all this does, this is just a DC-DC buck converter. It's just a DC-DC buck regulator. So all this does is take one voltage, a high voltage DC, and regulate it down to a lower voltage. So in this case, this potentiometer here sets the output voltage. It doesn't matter what the input voltage is, as long as it's higher. It doesn't even have to be much higher. If you have never used a switching regulator before, if you've only used linear regulators, you gotta get with the times. They're better in all respects. So we're gonna switch this over. Let's turn on our power supply. Should already be set to 24 volts. Very nice. Are we gonna smoke? We're not smoking. All right. So we're just going to hold this in place. So it looks like this comes pre-configured at the factory for 5 volts. That's a sensible voltage to have it pre-configured for. But we're gonna dial that up. Oh, this is a bazillion turn potentiometer. We're gonna turn up to 12, and we can always turn it down later. If it's too basically if the pump is too loud, we can turn it down. So let's see, we're at 11. Let's just bring it to a nice around 12. Normally regulators aren't accurate unless there is a load attached to them, right? Unless they're powering something. But these guys here usually have a burden resistor. Probably this guy possibly that guy right there. Basically, they have a resistor that always puts a load on it. So, hey, Cyberdeck Cafe, stop trying to poach my viewers. Okay, so we're set here. So this is going to... Alright. So let's put our toys away. John Isidore, thank you so much for the 50 Norwegian kroner. Good of you to take a break last Monday. It's a marathon, not a sprint. Could you talk a little about your meteoric rise to void stardom this year? It's... Oh man, thanks so much for the super chat. It's very generous. That really goes a long way to help support the channel. Yeah, actually the meteoric rise happened months ago. The channel's actually been growing very slowly over the last few months. But look, I'm not complaining. Or like, the response has been has been phenomenal. I'm blown away by how supportive folks are being. Basically, I mean, there's nothing to it. I just made videos people like watching. I mean, there's... Alright, let me explain what's going on here. Okay, so this is the extension cable that brings the pump into... I'll get back to the question in a sec. I just want to explain what I'm doing before we get too deep into it. This is an extension cable that brings the pump into the control board. And basically, we're going to get rid of this guy and put it on here so we can connect it to the pump, and we're going to just, I don't know, I think I have, I've got some two row connect, or I've got some two conductor JST connectors, so we're going to solder one of those on there too. So yeah, about the, I kind of expected that I would have to get to a certain point before anyone really saw the channel, before YouTube started promoting it, but I had a couple of surprise winners. Basically, before I started even recording anything, let's straighten things out because I know people love when everything's nice and square. Before I even started recording anything, I had a list of, I called it the crappy video ideas list, except a little more flavorful, you know. So I had the crappy video ideas list, and I was kind of like trying to conserve the really good ideas, and I had this idea for an Among Us video. I figured I want to do a video on Among Us, and that video ended up taking far longer. That's the exact video that came out, and that video took far longer than I expected. And yeah, anyways, while I was struggling to make that, I was running through the best ideas in the video list, and a couple of them turned out to work as well as I had expected. I guess I got very lucky, but I tried as hard as I before. Yeah, oh man, there's a lot of ways I could attack this. Basically, it's your fault. You guys are the reason why I still do this stuff and why the channel's done well. And my role in this was that I made some good guesses about what you folks would want to watch. But at the end of the day, none of this would have happened without your good taste. I know it's kind of a cop-out answer. But thank you so much for the super chat. Super chats really go a long way to helping make the channel work. And I just realized that the other thing that goes a long way to make the channel work, the Patreon, I still don't have the sponsor matrix in view. So I'm going to set... Jesus Christ! I just knocked the camera off the table. We're going to set that up at some point during the stream. We'll have a little intermission. But, yeah, this has been a hell of a first year. Although it's not, like, the channel's technically not... It's disingenuous of me to say I've been doing this for a year. Because the channel is much older. And I did make a serious attempt, briefly, to try to do YouTube. It's like 4 years... I still have those videos... I kept them up for historical reasons. But 4 years ago-ish... I made some videos. I made one on a data glove, and I made one on a Nerf blaster. And, because I was like, oh, I'll be a YouTuber. How hard could this be? And, yeah, video production sucked. Yeah, my setup was not conducive to it. So, technically, it took me longer than a year. But, yeah. But thanks a lot. I appreciate the question. I don't know, I was raised to not, it's a way of saying it. I was raised to not let anything go to my head, so this isn't something. I'm always more preoccupied on how much ground there is left to cover, versus like where I've gone so far. Alrighty, so this is the part that's going to the. Yeah. Christopher Mayfield asks, "Are we having another giveaway?" We certainly are not. We certainly are not. E3D, it was unbelievably generous of E3D to hook me up with this printer. To ask them to do it a second time would be a little much. Oh, I don't think that's, oh, hang on a second, let me just grab this cable here. Perfect. I never made that, I don't think I ever said that in either of the streams, is that they didn't give me the things to give away, right? Like they initially just wanted me to do a review, and I was the one who convinced E3D or not E3D. I was the one who convinced who were they? Anycubic and Ortur, or their representative technically, to do the giveaway. The giveaway was my idea. Oh wait, that's backwards. Everything's fine. Everything's fine. I know exactly what I'm doing. This is a great module, by the way. These I've been hooked on these buck regulator modules. That's the only thing that makes a linear regulator better. That's really the only way that a linear regulator is better than a switching regulator. Is that it's much easier to build into a breadboard. It's just easier to use because a linear regulator is really only one part, maybe with two discretes. But a switching regulator is it's a more complicated circuit, but it's an inductive circuit. It uses inductance to do its thing, and that makes it very sensitive to being on a breadboard. You can't really breadboard them. So these modules are normally I would just integrate the thing. Normally I'd implement a circuit myself, but these modules are definitely the way to go when it comes to buck regulators. So I grab them. Now, what do I need over here? I need some, here we go, we need some dual lock. So we're just going to stick a piece of, this is dual lock, it's sort of like industrial Velcro, but it doesn't, it's like industrial Velcro, but it doesn't have a loop side to rip, so it's very rugged. So we're going to use this to attach this to the back of the pump. And that way, we can dial our voltage up or down as necessary. Okay, good. So over here, so now we just want to connect these two. So let's see. For our wire loom to fit, we have to trim back some of the wire. So we're going to trim it back to about here, give or take. All right. So we're going to trim our wire. Yeah, we're going to trim our wire back to there so that the loom covers the solder joints. We're going to clip this with a hemostat. No, I don't want the big hemostat. I want the small hemostat to keep this from ooching its way forward. Yeah, and I'm going to need to grab some heat shrinks. I'll be right back. Where's our heat shrink? Here it is. I bought a lot of heat shrink. Heat shrink's one of those things that just, the size is so the size matters. Har har har. Yeah, but the size is so relevant that even though I have tons of it, I just never seem to have the right one. So let's strip these wires back a little more, make our life easier to solder. I should probably do this in front of the camera, otherwise this isn't a great stream. I am trying to get better at the streaming. This week was very important for me to stop and think hard. Stop and think hard about how to improve the stream. And I think one of them is that I have been kind of working on I've been kind of doing this stream in almost a Twitch style where people come and hang out for a while, but I wasn't respecting the fact that you folks are all on YouTube, and you are switching from a video, like a tightly produced video, playlist of videos, in fact, to watching me. So I'm going to try much harder to keep things faster moving. We're going to do fewer so all of my streams have been project related, but we're going to be making a few changes in the. We're going to be trying some stuff in the short term, the podcast thing. The podcast thing was worked out fairly well. I'm considering kind of integrating those. Maybe get some people on to yap while we hack, right? Get some people to talk to, so it's not just me, shooting the bull with you folks for hours. and basically just make it more like a video. I do really like the whole purpose. The whole purpose of running the streams in the first place was so that I can give you guys content, so I can entertain you folks while I move videos forward, while I move video projects forward. But I just don't think it's what folks on YouTube always want to see. You know, it's sometimes, you know, you folks know, sometimes building a project is, it's not exciting, right? Like, sometimes there's, you know, we have to think things through, or design a model, or wire something up, and then have to rip it out because it doesn't end up working. But yeah, I'm going to try to make it a little more like a show. Because I feel like that's why folks come to YouTube. I feel like I was doing the streams, I was making the same mistake that I said in my how to make videos video. I was making one of those mistakes. And that was, I was making the stream the way I wanted it. It's never, if you're in front of an audience, it's never about you. It's always about the audience. Speaking of, Justin, thank you so much for the super chat. This stream gets a 5 out of 7, perfect score so far. Oh, well, you're being very kind. I really appreciate it. We want a stream that everyone can get a kick out of. So, hopefully, I think, hopefully today should be a bit closer, because we're a bit more organized. We've got, the jobs are much better defined. So, let's get our, I made a mistake. See, this is what I was just talking about. I made a mistake. I forgot to put a heat shrink to hold the wire loom in place. I think we'll be able to get one over. I don't think this is catastrophic. We don't have to do anything over. But, yep, that's how building a project works. JW, thanks a lot for the super chat. New computer looks awesome. I love the RGB. I'm trying to solder an LED strip, and I'm having a hard time. Any tips? If you've never soldered... So soldering an LED strip is actually very similar to surface mount soldering. So if you've never surface mount soldered, it might be a little sketchy. So normally the rule is... Oh, this is too loud. Not going to be able to hear me. One sec. Let's shrink this stuff, and then we'll explain it. Shrink. The new hot air station is great for reflow soldering. It's not that great as a heat shrinking heat gun. It's not that it doesn't get hot enough. It's too hot. It's too hot and it doesn't move enough air. It's not really designed for it. Alrighty. So here's the trick. Normally the rule is that you never apply solder. Basically, like, you never apply solder and then melt it, right? Like, you always, like, try to melt the solder directly onto the part. Well, that goes out the window when you're soldering LED strips. Instead, put some solder on your wire, put some solder on the pads of the LED strip, and then just hold the wire against, this is a pad now. Hold the wire against the pad, and then just press your iron on it, and it'll melt the two together. Easy peasy. Super, super easy. Dr. McNumbers says lighters work faster than heat guns. That is true, but they also have a chance to burn. Pardon. They also have a chance to light it on fire. And I have lit far too many heat shrinks on fire. So this is self-sealing marine. This is self-sealing marine heat shrink that is lined with hot glue. So this stuff, actually, I don't think I even, yeah, these are all the same size. It's always the size that causes problems. So yeah, this doesn't just shrink, this also glues, and it's really important when you're using heat shrink to seal something like, like the fibers on this loom, because that will, because those fibers want to escape. And what better way to keep them from escaping than to glue them in place? Mr. Pomarelant, thanks so much for the CHF. I don't know what that is. Rip the old PC, but your video making the new PC is so refreshing compared to other YouTubers doing the same. I really appreciate hearing that. I watched a lot of other PC build videos and tried to figure out a way to set mine apart. And, yeah. The video is, oh man, I realized that I hadn't put a lot of... Thank you very much. I appreciate both the support and the kind words. I I realized that I was not putting in the same level of care on my videos. I've been taking the projects more seriously, but not the videos. I've actually been putting fewer, skits and bits and other stuff in lately. So for this last video, I decided to go back to where we started and make it 100% silly. Maybe we'll solder some LEDs. Maybe we might even solder some LED strips. That's one thing that I'm not sure how to do for this project. I'll repeat all of this if you can't hear me over my heat gun. Sometimes you just wanna say it. Look at that. It's all glued in place. Now there's no possibility. Yeah, now it's all glued. See, there's no way these little strands are going to ooch their way out. Focus. All right, whatever. It's not going to focus. So, yeah. So good. This should be about what we want. This side we have to be careful. Wait, do these fit together? No, they definitely don't fit together. Yeah. This one has barriers and this one doesn't. Alright, so this is going to go in the back of the pump. This side is going to go to the pump. This side is going to go to the motion system. We're going to start out by plugging these into the always-on outputs. And, yeah. AV3570 says, do you keep your Prusa stocked to have a reliable workhorse, or is it a riced-out machine? Wokeness of the phrase riced out aside, they are slowly getting more and more exotic as time goes on, because the design, I'm not going to say the design flaws, but the design choices of the Prusa are increasingly causing problems. So one of them is partway through being converted to all metal, because it PLA keeps backing up in it. And the other one, I actually, if we run out of things to do today, then this is something we're going to do. The bearings are actually, some of the bearings are dying on it, the little balls escape, so now it's squeaking and squealing. So I bought some of those plastic IGUS bearings with the lubricant permeated in it, impregnated, if you will. So we're going to do that. So slowly over time, they're getting crazier and crazier. I think I might upgrade one of them with a Volcano, because now we're going to have a spare Volcano. So yeah, over time they're getting crazier and crazier. That said, a lot of the mods I see people doing, like the Prusa Bear, to make the frame sturdier. There are a few of them. I don't think a lot of those are necessary. The Prusa. Alright, the reason a lot of those mods exist is to make the Prusa faster. And if you're trying to have a fast printer, the Prusa is a bad place to start. Like, if your goal is speed, you don't want a printer like that. You want a CoreXY printer, because that always puts two motors in control of the head. It's being dragged around by two motors, and there's less possibility for backlash and skipping because they're more belts. So that's what this guy is. This is a CoreXY printer. Not sure if you noticed, by the way. We'll show this in a bit, but the E3D is a CoreXY printer, and it's way faster than the Prusa. Even carrying this really, really heavy tool, it's crazy fast. I'm pretty sure, the top speed is twice as fast as... I think the top speed of the Prusa, I think, is, safely without skipping, is around 200 millimeters per second, I think. And, the top speed of this guy, I think, is 500 millimeters per second. It's crazy. I do what I want. I drink my coffee on stream. I don't care if you hear me slurp. I do what I want. Okay, so yeah, I'm gonna rearrange the camera. We're gonna rearrange the furniture a little bit, and let's rearrange the furniture a bit, and let's build. Let's wire up the pump and radiator, and then we'll give it a fill. Yeah. Let's put that here. I keep forgetting how to. This shouldn't be there. All right, excellent. So yeah, this will be my face cam. Let's get a little more light in the situation. I as much as I would love to have multiple Blackmagic cameras and multiple capture cards, I'm not that much of a baller. So yeah, bear with me one sec. I'm just going to rearrange this so that we can actually see what I'm doing back here. Okay, and yeah, I don't want to trip either. So we're just going to move this a little bit so we can see the liquid cooling system. Very nice. Alrighty. So looks like before we do, looks like we've got some super chats. Let me take a let's thank the folks who were nice enough to support the stream. Daruth the Eldritch Cryptid, thanks a lot for the Canadian pesos. Chill videos are better than heavy info dump, super serious videos. I agree, although I think there has to be some element of info, so it doesn't feel like you're wasting your time. I never want anyone to come away from my video feeling like, that was funny, but that's time but now I'm just a little closer to death. No, I want people to say like, huh, I actually learned something. I want people who watch my videos to later being like, their printer's not, they can't print their thing, and they're like, I think PETG would be better for this. Oh my god, did I learn something? That's what I want. GWR Films, thanks a lot for the quid. Enjoying the explanation of soldering LED strips. Are you thinking of doing BBC microbit projects? Oh man, BBC microbit. Oh, that's British. Oh, that's as British as it gets. The BBC microbit is sort of like it's sort of like an Arduino that was BBC, by the way. It's not that BBC. Get your minds out of the gutter. I know what goes on in my Discord. Get your heads out of the gutter. It's not that one. It's the British Broadcasting Company. Yeah, and so what is? So you might be saying, oh, hang on a second. That's not what's supposed to be going on at all. Perfect. So you might be saying, why is the British Broadcasting Company making computers? Like stay in your lane. But it actually is. It's not even the first computer they've made. Yeah, so it was built. It was built specifically for teaching kids programming. So it's sort of like an Arduino type deal. I have never actually used one. I've never actually used one. I'm aware of them. They've been around for a while, but I've never owned one, never used it. I don't. The big thing. Yeah, the big things that the BBC Micro has is first off, it's very easy to program for. You don't really need any tools. It's very simple. It's definitely the best. Here we go. Yeah, we're gonna upgrade this to a 2 amp fuse from a 1 amp fuse. The circuit board should handle it. I checked this. I love. This is why I love open hardware, because I checked the Gerber files, and the traces are wide enough to hold closer to 6 amps. So, and I don't think any of the parts that are doing the switching are going to have a problem with that. So let's cut the power while we work on it. Always a smart idea. Yeah, BBC Micro is easy to program with, which that's helpful. That's definitely a start. The other thing it's good for is it has an LED matrix built in and a whole bunch of capacitive touch inputs. So I don't know. I guess if I needed those if I came up with a project that could use those, then I would consider it. So yeah, let's see what we got going on here. Mr. Pupy Butthole. I'm going to turn on the fan because it's getting hot in here. It says, I'm not the baller, Zack. I'm also starting my FGC 9. Very, very nice. Thank you so much for the super chat. I see people testing the limits of the profanity detection in chat. Very classy folks. All right, let's try to wire this thing up the right way. Okay, so in the back of this, I just realized you can't see what the hell is going on. So I'm gonna. And now you still can't because the wire's too short. I need I kind of figured out some way to get a handheld. Someone with a Russian name I can't pronounce. Thank you so much for the ruble. What do you think about Voron printers? They've suddenly become very popular for fast printing. They have. I'm sorry. I just out of the corner of my eye I saw the web interface. I saw the web interface for this say connection lost, and I freaked out because I thought it was YouTube. But yeah, it's not. I turned this off. That's why the connection got lost. I don't actually know a lot about them. I should really familiarize myself. I think they're a particularly affordable. I believe they're CoreXY, or basically they're a very sturdy printer that's very affordable. So they've become a natural choice for anyone trying to speed it up. So yeah, you run into various constraints as you speed up a printer. The first is your hot end's ability to melt filament fast enough. The second is your ability to move quickly without skipping steps. And then finally, you have the ability to move fast without the frame twisting and warping. So, yeah. Oh, this is the wrong cable. That's why the other side is so weird. So let's plug this guy in here, and we're just going to test the fan is working. Which one is the plus? All right, here we go. Voltage is on the right. Okay, so let's turn this on, and the fan should turn on. You're just going to have to take my word for it, because there's actually, if I turn this 45 degrees, that would help a lot, wouldn't it? Yeah. I think so. Alrighty. So, yeah, let's turn this on and let's see if the fan explodes or plays nice. Fan is spinning. Fan is spinning. Very nice. It's pulling air in the right direction. Alright. Good, good, good. Okay. Let's, alright. Let's, in a second, I have to think for a second. Let's keep this on. I'm going to unplug the fan. We don't need the fan going. Let's fill the liquid cooling. I just realized that I should probably have the camera pointed at the liquid cooling, shouldn't I? Oh man, I just can't catch a break, can I? Hi there. So, bear with me one sec. I wish I had I had hoped to find a giant turntable or something that I could put this on, but it's just too friggin' big. This printer is enormous. Like it cannot possibly fit on my bench, and I can't possibly find a turntable or anything that'll do the job. But yeah, let's not let that get us down. How are we looking on light here? I think this looks alright. It could be a bit better. I'm going to open up the aperture a little bit, and boom. Alright. So, let's fill this thing up. So yeah, we're gonna open the top here. We're filling this thing with distilled water. We're gonna start with distilled water, and then we're gonna run that for a while. Maybe we'll drain it out and replace it with more water, and then we'll throw the coolant in. Yeah. So we have a whole bunch of distilled water. I forgot this is much. The reason I was panicking a little before is because I forgot that this is a much smaller system. It's a little up. Yeah, so this is a much smaller system than a PC liquid cooling. Yep. So we're gonna fill this thing up. Yep, this is it's a much smaller system than PC liquid cooling, so it's not gonna use much water. For a PC, I typically need about 4 liters in total, like 1 to flush, like 1 or 2 to flush, and 1 or 2 to, like 1 or so to fill it, and then a bit extra in case I have a leak or something. Let's fill this. This is taking a very long time to fill. I'm losing my patience here. All right, let's take a look at chat. Let's take a look at chat. Let's see. Oh no. Based on what I said earlier about BBC... Oh, no, I'm not following that one. Oh, by the way, I noticed Rene is here. I acknowledged you before, but how's it going? Rene worked on the... he's not an employee of E3D, but he's worked on the Toolchanger, and he's been helping me a lot throughout this build. I would definitely not be as far along as I am without his help. So let's fill this up. Let's see. We got any interesting chats So today, we have a couple things to do. Suicune Games says, "Hi Zach, what are you doing in this live stream? I was late." We are finishing up the E3D Toolchanger, or at least continuing it. This is basically a not super advanced, but it's got it's a pretty over-specified 3D printer with a lot of different extruders in it that get picked up by an automated tool changer mechanism, and we're going to try to finish the job. It's going to be pretty fun. Also, the stream is sponsored by Things. No matter what kind of printer you have, whether it's an E3D tool changer, or it's a Prusa, or it's a Voron, I don't care, whatever it is, head to things.com to download all kinds of 3D printable things. This should probably be like so. Yeah, go to things.com to download all kinds of 3D printable things. Yeah. They've revamped the site, made it super easy for anyone to upload anything. And on the inverse, regardless of what you're looking for, and no matter where it is, Things searches all kinds of 3D printing STL sites across the internet. So, yeah, when you're done with your next project and you want to share it, or when you're interested in starting a new one, use the link in the description to go to things.com. All of my stuff is there. Check out their augmented reality. That's pretty sick. They got that working on, I think they got that working on Android now. So no matter what platform you have, you can see your stuff in augmented reality. So yeah, and thanks a lot to them for helping make the stream possible. Without further ado, let's wire this thing up. Let's hope nothing explodes. All right, so polarity is correct. Let's connect to this. This is our voltage regulator that we were soldering up earlier. Should probably stick this somewhere. There isn't a solid point to attach this to in back here. I guess we could zip tie it back here. CoreXY, thanks a lot for the quid. BBC Micro was released in the 1980s. Were you thinking about the Raspberry Pi? What am I thinking of here? There's no way it was released in the 80s. It's got like an LED matrix and like capacitive touch and stuff. Like that's. I'm just gonna stick this guy over here. Like those aren't 80s technologies. Those are modern technologies. Maybe there are multiple different devices called the BBC Micro. Is that possible? I know the BBC did release. I'm gonna zip tie this all together because I'm worried about it catching on something and getting yanked. I know the BBC released a number of educational computers and microcontrollers, so it could be possible that we're both correct. They released something in the 80s and they released something different in more modern times. So who knows? Oh, the micro bit. Am I mixing two things up? Is there a micro in the micro bit? I might be mixing some stuff up. Yeah, to be totally honest. It's been a long time since British, except for the Raspberry Pi as a notable exception. Like, it's been a while since like the days of Sinclair, where British electronics were well known in the States. Yeah, Americans really don't. I don't know. I feel like we don't always keep a good watch on what's going on in Europe, even in something that should be global, like engineering. So let's wire this thing up. So here's what we're gonna do. I'm gonna connect this thing just for a sec, because what's gonna happen is I'm gonna plug this thing in at the back, and the pump is going to turn on and the water level is going to drop as it fills out the rest of the system. Now it's really important that we have to stop the pump before the water level drops, because the pump needs water or it'll burn itself out. It uses the water cools and lubricates the pump in addition to cooling the printer. So we got to keep a close eye on this, and there's a chance we'll blow our fuse as well. So let's see. Nothing's happening. Nothing happened. All right. Let's hope nothing is damaged. Nothing's very hot. So I don't know what's. Let's see. I'm not sure what's at play here. This is part of the fun I suppose. Let's think here. I'm just going to grab... It could be that this just draws too much current, you know. If it is, then no problem. We'll just hook up a second power supply. I'm just going to probe the... I'm just going to probe the fan outputs to make sure there's actually still 24 volts moving through it. Yeah, it looks like it still says 24 volts. This thing should be rated for up to 3 amps, so I'm not too worried about that. Here's what we're going to do. I'm going to connect this back up to the bench power supply, and we will power it off of that and see if there's any difference. It could be, it could be like just some mistake, like a wiring mistake somewhere along the line. This is only this is a 3-pin device, even though we're only using 2. So I don't. So it's not like we missed a PWM pin or something. So yeah, let's connect this guy and we'll connect this guy and we'll switch it on real quick. Let's just see what happens. It's definitely being powered. I don't know why it's not running though. Let's all right. So this is being powered. Let's measure the voltage coming up, because it could be that now that we've put a load on it, it's outputting a lower voltage. It says 12 volts. There's something funny going on here. No, it's definitely running. Huh? That's really weird. It's definitely turning, but there's no water moving around. That's not good, is it? Oh boy. Of all the things I expected to happen, that was not one of them. Well, crap. It's definitely turning, but no water is moving. Is this... Rene, is this something that happens, something's happening often? Let me move the mic around. I do need a lapel mic, but the wireless, with the wireless pack is just too expensive. It's like hundreds of dollars. Robin suggests it's missing the pump impeller. Sumner suggests there's an air pocket in the pump. Either of those could be correct. So let's it could also either of those could be correct. So let's maybe the pump's not primed. So I'm gonna knock it to. I'm gonna bump it to knock the air bubbles out. Try to get more water into the bottom part, into the pump, because it's got this very complex grill thing on top. Ryan 3003 says that pump, I had the same issue. There's air trapped in there. Yeah. All right. So it's just not primed. A pump needs to have, some pumps need to have water in them, or whatever they're pumping before they begin. It's called priming. So, yeah, let's see if that had any effect. If it didn't, we'll get a little more aggressive. Oh, there we go. All right, check that out. So this isn't the most powerful pump I've ever seen, but it's definitely going. Not the strongest pump. It's actually a little on the wimpy side. Is it even pushing the water through? I think it is. Still a lot of air bubbles trapped in there. So yeah, we're gonna restart it a few times to kick out more air. So it looks like this just isn't a tremendously powerful pump, which is fine. Like, the cooling requirements of this thing are a lot lower than a PC. Let's say. All right, come on. Come on, let's get it out of here. I kind of expected this to be more dramatic. Might not be a terrible idea to take the pump off, or take the radiator off and wiggle it around. But I seem to be able. It's also a very small system, so That's pretty cool, though. All right, it looks like it doesn't look like much is happening here, but it's definitely moving. I'm pinching the tubes a little bit to briefly increase the pressure so we can drive more bubbles out. All right, so let's turn this off and on a few times. The change in pressure will knock more bubbles out. So, okay, it looks like then we're not going to need... all right, so I unplugged this from the lab power supply. And let's turn that off before we create a short. Let's plug this back into the E3D... let's plug this into the duet board, the driver board, and we'll make sure that it can power it. All right? All right, it looks good. I'm seeing bubbles moving. I really wish this had like a flow indicator or something. But yeah, we're getting bubbles through. Okay, so we're gonna leave this thing running for a little bit. Yeah, we're gonna leave this thing running for a bit to clean out the system, to check for leaks, and to just, I don't know, improve the tempo of the show. We're gonna leave the cap off because we want to burp any air bubbles to escape. We want to burp the system out. Otherwise, we might build up a little pressure in here, and like, honestly, like this, I'm not too worried about anything coming loose here because this is a soft. It's basically it's sort of a hybrid system because these tubes up here are more rigid, and yeah. I could pull the radiator off and turn it around, but it's not a lot of fun to install and remove. But yeah, let's give the pump and radiator a little shake. Yeah, let's give this a little shake, and then we'll let this sit and do its thing. All right. But yeah, has anyone else ever seen a water cooled 3D printer? They're actually not that uncommon in industry. Professional 3D printers are often liquid cooled. It's not nearly as exotic as I thought it was. So it looks like there aren't actually a lot of bubbles trapped in there anymore. But yeah, we'll let this do its thing. And yeah, isn't that rad? So I'm just going to get a quick look inside to make sure there's nothing leaking. I'm not seeing a single drop anywhere, although I think I'm missing some clips. I think these connectors in here should really have clips, and they only included 2 sets. But they only included 1 set of 2. So yeah, let's see if anything drips. The water block, right? The part the water flows through is on the opposite side. It's basically the opposite side of a chunk of metal to the extruder. So even if this drips, it shouldn't drip on any electronics. So yeah, let's let this do its thing. So yeah, cool. Alrighty, so yeah. Rene and says, show us and shake T0 around for the bubbles. Alright, yeah, let's give this. So yeah, see how what's going on here? The tubes are going the tubes are following the Bowden and the electronics, and they're going into water block here. So let's give this a little shake. This actually seems to be pretty, either the bubbles are really tenacious or this system is particularly well behaved. It doesn't look like there are a lot of bubbles trapped inside. This isn't a very complex water block, like it doesn't have any cooling fins or anything. Ooh! Oh, that was a close call. I almost dropped it. Let's just make sure everything is nice and tight. Okay. I lined the... during testing, we're going to be during testing, and because of my Butterfingers, we're going to be dropping these a lot. So I have lined the bottom of the Toolchanger with foam. See the black in there? I've lined the bottom with foam because I know I'm a giant klutz. This is looking. We're in pretty good shape so far. I actually, now I'm thinking about it, really wish I had some strain relief on this voltage regulator because these wires are just dangling there. But yeah, let's let this do its thing. Let's try to avoid knocking things around too much because it is an open container of liquid. Yeah. So we'll let this run for a while, and then when that's finished, we will, yeah, we'll let that run for a little bit. At some point, maybe we'll drain it and pour in and put in some more water, and then we'll add in our coolant. I have some E3. I have some EKWB what is it? Cryofuel. I got some cryofuel premix because this is an aluminum system, and most off-the-shelf coolants are not. They're not designed for aluminum. They'll actually corrode it. So I had to go out and do my research and find a I think it's a polyethylene glycol based coolant. Yeah, it's all very scientific. So yeah, let's let this do its thing, and let's actually, while we're down here, well, first order of business here is we have to update the to-do list because people keep busting my chops about updating the to-do list. So let's so we're gonna head over here and let's get that done. Yes. So some folks were asking, like, why not go completely crazy and, you know, make like why not go completely nuts and do like a, oh hey, this should be over here. Do like a multi-fan system of craziness. It's not necessary. Even this pissant little radiator and pump is more than it's way overkill to cool the system. Like, the limiting factor is going to be how much heat the water block can pick up. Yeah. Rene has screenshotted has screen capped me dropping the. Screenshotted me dropping the Titan and causing all and sent it to me. That's going to go down in history, isn't it? That was a real Linus moment. That part actually, we actually got through that a lot quicker than I expected. And the menu for the monitor is on screen, and I don't know how to get rid of it because there's no back button. Oh, for crying out loud! Alrighty. Rene says it's like 5 watts of heat. It's just a water block, right? Like, or it's just an extruder, right? Like, there's so little heat in this that a 40 millimeter, like a tiny ass 40 millimeter fan, is capable of dealing with it. All right. So the next thing to do is to heat and calibrate the system. This is going to be all kinds of fun on a bun. I have to actually look up how to do this. As you can tell, I'm very prepared. So let's. So here's what I'm doing. I'm raising the camera so that we can get a good look at the proceedings. Let's lock that in place. I hope this will do the job. Let's see. Let's switch back over to that. Yeah. So this job is going to be done partially on the computer and partially on. There we go. This is going to be done partially on the computer, and it's going to be done partially in in real life. So I am. All right. So here's what I'm going to do. I'm going to modify this scene right here. Here we go. I'm going to overlay the web browser. So let's put this. I think this will work. Yeah. Like so. Okay. Awesome. All right. So I'm going to overlay the web browser. I'm still not 100% on OBS. Alrighty. So we want. This isn't Chrome. Haha. This is Edge. Okay. Edge. Who's ever played the game Catherine? If you have, if you have, then you are probably traumatized by the word edge. Scale this down. All right. I wanna overlay this so that I can show everyone what is actually going on here. This is way smaller than I expected. All right. I think that's enough. I think that'll do the job for now. All right, so yeah, this is the web interface for the 3D printer, and yeah, we're going to be using this to get the job done. Okay, so first let's home the system. Homing always has a little bit of a delay because it's got to home the C-axis, the coupler. Yeah, which is pretty odd. You know, just so you know why it's looking like nothing's going on. Okay, so here's what's going on. We need to calibrate. We need to change some settings for each of these, so that it basically it knows what the difference is between the position of the Toolchanger carriage. This away, yeah. It needs to know the difference between the position of the Toolchanger carriage and where the actual hot end is sitting. So yeah, let's do that. Yeah. So we're gonna go to so we're gonna check this out on E3. So I didn't. All right. So I made a mistake here. Part of the reason we had so much trouble is because the documentation, right? The link that's included on the sheet, the link that it says to check out, this documentation right here. I got this from a link included, in a piece of paper with the printer, but this is incorrect. This is actually an old set of documentation, and this is the correct documentation. So we've been looking at the wrong documentation for this whole time. Anyways, now we're going to do the. I think this is it. Fine-tune Z offsets. I think this is it. Load the files and prepare. So let's see. This is a script that's going to heat the bed nozzle, park the nozzle, and rehome the Z-axis. Build a raft 1 millimeter tall. Iron the top flat. Park the tool. Oh wait. This is all right. We're not quite there yet. All right. The other problem is that these tools are all custom, and one of them is extra custom. Two of them are, yeah. So basically, we need to program in these offsets, and I think the instructions are in here. I've already gone this far. I think we also have to check that tool number 2 is coupling. There are a few tasks to do. Pardon me if this seems aimless, but this is what I've been dealing with for the last few days. Okay, so we've already done this. We've greased it all up. The hot end fan is configured. Okay, so all right, we got a few things to do here. Yep. All right, we got a few things to do here. I'm going to let's switch this back. All right, so I'm going to adjust the camera a little bit because the first thing we have to do is trim the Bodens. I almost said trim the Bidens. I don't think they need any help with that. So check this out. So, or not the Bodens, but the pickup tubes. So yeah, I haven't trimmed these at all. They're way too long. So we got to cut those so that we can start loading some filament. So here's what we're going to do. We're going to cut that. We're going to get a spool of filament in one of them, and then we're going to heat up the system. That'll enable us to do two things. First, it'll let us tighten the system down. We can't do any calibration until we've done hot tightening, because otherwise the Z-axis will be a little bit off. And that'll also let us test the various cooling fans. We can turn on the part cooling fan ourselves, but the extruder cooling fan only turns on when when the extruder reaches a certain temperature. So I'm going to grab my tubing cutter and let's get down and dirty. Yeah, let's see. Should be able to still hear me. Looks like everything's coming through loud and clear. All right. This is a bit of awkward tight quarters, but yeah, these are too long. Let's cut them down to size. So Rene, how long do we want these to be? Is this all right? Like just going into the corner. This is a very awkward layout here. I'm gonna rearrange the furniture a bit more. Yeah. So we want this thing like tucked into the corner and looping back around here, right? So probably, what do you think? Should we cut it around here, or do you think we need to get rid of even more slack? I guess you can't really see because we're blocked behind our to-do list. So something like here, right? That seems to do long enough. It's a bit of a, oh geez Louise, can't see my face. A bit of a measure twice, cut once kind of thing. 860 millimeters total. Hot Titan without filament. Yes, we're going to do that. The total length is 860 millimeters. All right. I don't have a metric tape measure, so, and I also would rather not pull this thing all the way out. So, yeah. All right. Fine. I guess it's just Teflon, so it'll be easy to pull out. Oh no, it seems to have gotten tucked under the printer. All right. So I'm pulling this out. There, you guys cannot see literally anything. Oh, this is a real nightmare to keep in frame. Oh wait, that's not what we want. We want this.
Do you take like centimeters?
Huh?
Do you need centimeters?
Yeah.
Okay.
Yes, Brooke, we need centimeters.
Well, like, is this such?
Oh, hey, is that a measuring tape with centimeters on it?
Yeah.
Oh my, that is so convenient. Hang on one sec. I'm just centering this. Very nice. That's what we want right there. All right, Brooke. Way to go. Look at that. It's all metric and stuff. Cool. I just want to cut it too far. Yeah, so we'll cut all these down to, let's just confirm, 860 millimeters. I've got my tubing cutter here. Way easier to use a tubing cutter than to try to cut it by hand, because Teflon is very slippery. Also, has anyone here ever tried to cut Teflon with... Anyone here ever tried to machine Teflon? You ever try to cut it with a lathe, or with even with a power drill or a Dremel? Anyone know what happens when you do that? Because it is hysterical. Basically, it turns into ribbons and goes flying everywhere. It sprays these like ribbons of Teflon all over the place. The stuff is impossible to work in any way. Okay, so we want 860 millimeters. Yeah, it can't be 860 centimeters. It's way too long. All right, so here we go. I'm going to cut this at 87. Actually, we're going to measure twice and cut once, because I used to be a Boy Scout a very long time ago, and yeah, I don't think the Boy Scouts taught me that. I think it was my grandpa. My grandpa had he was like a ham radio operator, and he had an awesome workshop. I thought it was like the coolest thing ever. And every time we went to see them in Canada, that's all I wanted to do. I just wanted to hang out in there, and he had these he was like one of those like reuse everything types. So like all of his workshop stuff was like salvaged or something. This is very short. Did I make a mistake here? I think I made a mistake. This is far too short. Yeah, this isn't even coming close to reaching the filament guides. What's going on here? What did I mess up? This is 87. Yeah, what's going on here? What did I mess up? Oh, jeez. Yeah, knocking them off is a bit of an occupational hazard here, isn't it? Alright. I'm committed to avoid fumbling around, so if I ever get confused, we're just going to skip that part, and we're going to move on to the next part, because I want to build this printer, but more than that, I want to give you a show. So let's see, this is 87 centimeters, but it's not even close to enough to not even close to enough to reach the filament pickup. What's going on here? Let's see. Am I supposed to cut 85 centimeters off, or is it supposed to end up being 85 centimeter? 85, or am I supposed to cut off 86 centimeters, or does it end up being 86 centimeters? Oh no, the 86 centimeters is for Bowden tools. Oh no, that seemed short to me, but I trusted you, Rene. I trusted you, and look what you've done to me. You've ruined me. I'm just busting your chops. Yeah, we can always 3D print like a coupler. I don't think I have any extra, so we'll have to couple it together, but we'll do that afterwards. All right. What do you say we eyeball it? Yeah, Rene. Well, there's only one way to redeem yourself. You gotta let me know what the you gotta let me know like what the correct amount should be. Can I get an F in chat for the fluorine in the PTFE tubing that has now gone to waste? I'm guessing that it should be about this long. Yeah, it seemed a little on the short side, but whatever. Them's is the braces. SP Roach, thanks a lot for the super chat. Heck with it. I sent this by Twitter. Here's the super chat anyways. Thank you very much. I really appreciate that. Thanks so much for supporting the channel. F's for days. Alright, this isn't a big deal. We will just 3D print a coupler and, let that couple it. Alternately, I might even have a piece of tubing lying around that we can just jam these in. This isn't like under pressure, right? This is just a filament guide. So, I'm not terribly worried. So, yeah. Let's, I think we'll just eyeball this one. Put this in about here. Let's actually give it a little bit extra. All right, let's give this the snip. There we go. Let's switch back to camera. Oh, I left it on the desk. Dang it. Let's get this guy in the filament holder, like so, and we'll move around to the other side. Get myself my number pad. All right. There we go. Let's see. We got a lot of F's. Ripperoni and pepperoni. Rene says you can do 1.6 you can do 1.6 meters, and it's still pretty long. All right. I think it's just a filament guide. I think any lengths would be about estimates anyways. I think it matters more to a Bowden because you gotta bend it. But this is just a filament guide. So we'll err on the side of keeping it a little long, because you can always cut off, but you can't cut on. This guy will cut it about here. Why are the colors so saturated? What the hell's going on here? I upgraded the firmware on the Blackmagic camera, and it has been acting up like crazy. It's been raising all kinds of hell. It's been raising all kinds of heck. Probably gonna want to add some guides to keep these, or, some sort of bracket or something to keep these filament guides from getting in the way of anything. But let's put this guy over here and loop it back around. Probably want to snip this. Let's call it here. You can always adjust. You can always adjust later. Nice, generous bend radius. This thing, we're going to run out of filament and during prints, and it's going to cause all kinds of problems. Because this is a super long pickup distance, or whatever the term is, and it doesn't have a run out sensor. It's the one way this thing isn't ultimate. It doesn't have a runout sensor, so we have to be careful. It has a place to plug one in. It just doesn't have one installed. Okay, so this one is a little short. We're going to want to make a coupler of some kind. Alternately, is the remainder long enough? It's definitely not. Yeah, we're gonna have to make some sort of coupler. Okay. Let's head back over to. Oh, that's not what we want at all. All right. So back over here, and let's quickly fire up Fusion 360 and whack together a PTFE coupler. This is only going to take a second. It's really only one detail. Where did I put my calipers, though? That's therein lies the rub. I can't do much modeling without my calipers. Where did I put them? I probably... Oh, crying out loud. This is why I don't like when projects go on too long, because the workshop gets so kerfuffled. I guess I was working on the wiper. I actually put one on both sides, and because I'm an idiot. I should have only put one on one side. The other one is not even close enough to matter. All right, where is my calipers? I'm having. This is the toughest part about streaming. Is like you have to be immaculately hyper organized, because every time we hit a setback of even a few seconds, we just lose like 30 people. Just cheese it.
Here are your calipers.
Why are my calipers there?
I was calliping.
Why did you take my calipers?
I was
The hell
calliping.
That's a plot twist right there. I didn't see that coming. Brooke, give my tools back after you're done.
I love you.
I love you so much. Stabbed in the back by my beloved wife. Anyways, that really threw me for a loop. All right, let's give this a quick measurement. This is it's just over 4 millimeters. It's nominal 4 millimeters. Nominally 4 millimeters. Rene says you don't even need to connect it sturdy just for feeding in. As soon as the filament's in, it's holding itself together. I know, but we're going to be changing filaments very often. Brooke was calliping. That's right. We're going to be changing filaments often because we're setting this thing up for an every 3D printer filament episode. So normally I would be this precious, but we have our space mouse. I've been practicing. Okay, so we want this to be 4, and we'll give it a little bit of leeway. We'll call it 4.25. And we'll surround it by a hexagon, because I love hexagons. They are, as I have been told, the bestagons. So we'll, let's see, we're going to connect these with a line. Okay, so this is just going to allow us to set a wall length without having to take into account the dimension of the circle. Check this out. Okay, so we want this to be 2.4? 2.4 is usually enough. Brooke was calliping. All right. So let's see. This is 4. We're gonna put one in the center so we can, or we're gonna give this a little lip. So we're gonna give this a little bit of a lip to make it easier to center both of the pieces. All right. Yes, we are making another Every Filament episode, and this time I mean business. This time I mean it. When I say every filament, I mean every filament. We're just getting everyone I can find. Let's make this 2. Every filament I could find, we are throwing in this episode. So let's see. So we're going to then let's make ourselves a nice little how long should this be? Let's call it around 10 millimeters on the side. 10 millimeters on the side. I think that's all right. So 10 millimeters this way, and extrude again. No. We want this, and we'll start from here and call it 10. There we go. All right, very simple coupler. It's gonna feed in about 10 millimeters. I think it should be fine. Very nice. No one asked, do people actually use PEEK? Yeah, it's pretty common high temperature material. In fact, the standoffs that are on this printer, the standoffs that connect the. Actually, am I going to need to? I'm going to tent the. I think I'm going to tent the top of this. The standoffs that connect the heated bed to the frame. Words. There's words. How do I use them? Yeah, those things are. What? Can I not change the number of sides on a polygon after I've created it? Oh, that sucks. Those are made of PEEK. It's really hard to 3D model and talk at the same time. Let's see. It's doing both at the same time. Oh man. No, that's not what we want at all. Alright. Cool. So, we'll just drill this out. So let's lay this down on its side. We'll print this on the coccolith. We're printing it out of PET. It should already be loaded. We'll make this at high quality, add a brim, and go. I'm just going to quickly scrape off the remnants of the last print because they're still on there. There we go. Get out of there. There we go. Okay. So while that's printing, let's move on. Let's move on. So we'll do some hot tightening. Yeah, I gotta drill it. Normally I compensate. Normally, I try to compensate it so I don't need to drill it out, but it's just gonna be faster. Yeah, it's just gonna be faster. I know, I don't. Alright, so what's going on here? The reason why it's not keeping the horizon level, the reason why it's doing this, is because it's up to the app developer to implement how the Space Mouse behaves. And they haven't made it axis aligned, or they haven't made it horizon aligned. And there's no switch for it either. Like Autodesk needs to implement that, and they won't. So yeah. So get disoriented. We're done with this anyways. This part is over. We're gonna get down to there we go. How do we want to do this? We'll get down to hot tightening. Let's set up the camera at an offset here so you folks can actually see what on earth I'm doing. There we go. How are we doing on focus? I'm using a narrow aperture to try to keep a lot of this in focus. So where should we start here? I guess we'll just move. Let's see. I guess we'll just move from 3 back to 0. Alrighty. So let's roll. The Real Hubster. Thanks a lot for the super chat. Your channel's a huge inspiration, Zack. Best maker on YouTube, period. Thanks for making the learning curve with 3D printing fun. Thank you. I didn't really intend my channel to be beginner friendly, but I'm glad it's helping so many folks get into this. I really appreciate the support. It means a lot. I'm missing a lot of super chat, not super chats. I'm missing a lot of Discord messages, but that's all right. We're not doing Discord. We're doing 3D printing. So okay, let's do this. So let's switch back to our Toolchanger, and I guess we need to pick up a tool in order to work on it. So let's pick up tool 3. Come on, drop the bed, drop the bed, drop the bed. Drop the bed. All right. I'm still getting used to the coordinates on this. Let's move this so it's centered. There we go. If you hear a crackling noise or crunching sound, those are the failing bearings on my Prusa that I was talking about earlier. So, yeah. All right, so let's grab ourselves. Actually, let's pull this back a little. Yeah, let's grab ourselves some tools and make it happen. So I'm assuming this is all metric. Which one of these is metric? See? Ah, here we go. All right, so let's see. So in order to tighten this, we're going to need one. That sound is cheesing me out. So in order to tighten this, we're first going to need to move the friggin' camera so you can actually see me. And yeah, we're going to need one to hold the printer. We're going to need one to hold the block, and we're going to need another to actually do the tightening. And I forget what the dimensions are here, but that's fine because I should have a nozzle lying around that I can just test with. Let's see. Here we go. We got some. Oh, hang on a sec. Hang on a sec. We actually got a little ahead of ourselves here because we were going to upgrade the Volcano. So, unfortunately, oh man, I bet the thing that just showed up. So I ordered some thermocouples. I'll explain what that means in a sec. There's a lot going on here. So pardon me being a bit scatterbrained. There's a lot going on. Here we go. It's the smallest one. Very nice. All right, so we're going to need these. And we're probably also going to want some Allen keys. Very nice. I love this set. It's so good. So first order of business is to upgrade the Volcano on this one. Where did I put the high temperature Volcano heater block though? That's the question. Because we can't do one of the mods without the others, and I thought I had them all in a huge pile right here on this chair. Oh, did I knock it on the floor? There's been a lot of commotion here lately. Roscoe the dog is being a real handful. He's been very distracting. He's been a bad boy. He doesn't. He's not a bad boy. He's a puppy. Puppies are just rambunctious like that. Crap. Where did I put the heater block? I had everything laid out and handy, and then I lost all of it. Poop. I guess we could all. Yeah, I don't have to do this all twice. So, damn. Burke, you didn't take the copper Volcano heating block, right? Because normally I wouldn't accuse you of something like that, but there was an incident with some calipers. Well, poop. All right. Yeah, I bought a whole bunch of parts from McMaster to help put this thing together.
Yeah, I was volcanoing.
Yeah, you were volcanoing?
I wasn't really. Is there something that you need me to pick up for you?
At the hoop?
Yeah.
I don't actually know what it is, but maybe. Maybe we could also wait a bit.
Okay.
Yeah, if the pupper needs a walk, then go ahead. I
thought you might need that part.
No, it's already arrived. All right, well then, crap. I have lost it. Damn, there's so much stuff flying around here. It's so hard to. Oh man, this is far beyond my ability to stay organized. Oh Christ. All right, so basically, you can't use an aluminum. All right, so basically what's going on here is these things are fitted with like aluminum heating blocks, right? So we've got we can't pull it off because it's engaged by the Toolchanger. I'm dumb. All right, don't worry, we're gonna get back on track. Oh man, streaming on YouTube is really stressful. People leave if momentum drops for even a few seconds. People cheese it. Oh right, this isn't a touchscreen. That's why touching it isn't doing anything. So let's drop that off. Please don't pull it out. Okay, rad. So let's move this out of the way. All right. So this Volcano is going to be used to print high temperature filaments. Yeah, we've got Volcano, and we've got the Titan, and both of those are going to be used to print high temperature filaments. And in order to print high temperature filaments, we need to make some upgrades. First off, the heating blocks, right, can't handle such high temperatures. These already have all metal heat break. These already have all metal heat breaks, which is part of the requirements. But we need to replace the aluminum blocks with copper blocks that can handle the higher temperatures, and we also have to replace the nozzles with hardened nozzles that again can withstand the heat. And finally, we need to replace the thermistors with a thermocouple. A thermistor is like a resistor, and the resistance drops as it heats up. And that means that a thermistor has a maximum temperature that's capable of sensing. Because when it, think about it. Like if the resistance drops as it heats up, then that means there's a certain temperature where the resistance drops to basically zero. And past that point, can't measure anything. And the ones that are commonly used in 3D printers are calibrated so that happens at around 300 Celsius. But we have to go to 400 and have a little headroom. So we're replacing that with a thermocouple. Hopefully that's what showed up, because the thermocouple is capable of reading like thousands of degrees. The thermocouple also is going to need some special electronics, but I bought that too. So we're going to be throwing a daughter board onto the Duet module, and I've been buying time for a while, and I have completely lost the block. I wonder if it's still on the kitchen table. All right, so we're going to forget about that, and I'll just replace that later, because my objective here is to show you what's up. Okay, so we don't have the thermocouple, we'll add that later. We don't have the block, we'll add that later. We do have the nozzle. So, yeah, this is a high temperature nozzle. This is an E3D Nozzle X. And the Nozzle X is, I think it's like steel or some sort of copper containing steel alloy with a coating on it that makes filament less likely to stick to it. At high temperatures, remember, filament burns really easily. So, there we go, that's a little better. Alright, so we're going to unscrew the old nozzle. Brass nozzles cannot work at high temperatures. They will soften up and come apart. Even if you're not running abrasive filaments, at high temperatures, they'll fall apart. I think this is copper, which is also important because at high temperatures, steel nozzles will actually lose their temper. So you use a hardened steel nozzle to resist bits of carbon fiber and metal particles and other fills in your filament. But at high temperatures, it loses the hardening. It just becomes regular steel, and it's not going to help you out. So I had hoped to replace this block here, but it's either in this room or it's in the kitchen. But you guys don't want to watch. You guys and gals don't want to watch me rummaging around for it. And I'm saying too much because there's too much on my mind. Okay, so there's that. Alright, so this guy, here's the Titan. This already has this already has a copper heating block. This also needs a thermocouple, which hasn't shown up yet. And this has a much more powerful heater. This thing is fitted with a 65 watt heater, which doesn't sound like a lot on paper. But a Prusa, which is considered a pretty hot printer, its heater cartridge is only 20. I think it's like 30 watts, 25 to 30 watts. So this thing is more than twice as hot. This thing is more than twice as hot as my existing printers. Looks like this is printing all right. Okay, so E3D also sent me an entire set of these nozzle X's. We are going to be using, for this one, the 0.5 millimeter. I prefer 0.6 personally, but it doesn't matter as much here because we're gonna have to make our own slicing profiles anyways. So we're gonna use the 0.5. We want a wider nozzle because we are going to be printing a lot of composite filaments. So let's get that in there. I wish we had a thermocouple, but we can do all this just fine without it. Thermocouple is just a bit of a, it's just a minor software change later. Or it's just a, yeah, it's just a minor software change. I think when we get back, I'll check on our our deliveries and see what I'll check on our deliveries and see what is being shipped and what what's arriving when. Because we're expecting a bunch of stuff that we could use this stream. These two are already all right. These two here are already configured properly. So these are already configured properly, so we're good to go. So these are the nozzles that we're going to end up using. Let's do some hot tightening. This is, by the way, this is the first time that I have ever heated these up. I've never heated these nozzles up so far. I wanted to save that for now. So, yeah, I'm gonna hone this to make sure that bare minimum of stuff goes wrong. Let's double check that our camera angle looks good. Let's turn this this away. All right. Does this thing think it's holding anything? Nope. So let's start by hot tightening the Volcano. So first we'll pick it up. It's so amazing that this thing works. It was really rough to get this configured and set up. Yikes. We have to be careful about collisions. This doesn't have a lot of protections in it. So it's a real, this is one of those situations where we can't count on the machine. Basically, this machine is not idiot-proofed at all. So, idiocy will be punished aggressively and immediately. Oh, this is still not a touchscreen, he said, talking about idiocy. Alright, I'm going to try to zoom in here so everyone can see what I'm doing. Actually, you're not really going to be able to see what I'm doing because there's no good angle here because everything's being blocked because this thing is so friggin' chonky. Alright, let's move this over here. I knew that this would be a bit of a finicky stream. It's kind of the nature of the beast, I think. This is very much not an enthusiast printer. This is, I don't know. I guess if I really knew what I was getting into, I might not have decided to do this because this is a little beyond my ability. But no sense in complaining now. Alright, let's prepare for our hot tightening. Oh wait, that's not what I wanted at all. Haha! Alright. Good. Okay, so let's do this. Number three is Zack is going. So let's. The instructions say to set this to 285 Celsius and allow it to hang out for 1 minute. All right, is this going? Oh, this is active temperature and standby temperature. Okay, it looks. Oh, the standby must be like the temperature idles at when it's on the rack. Rene says no need to have it picked up for hot tightening. Yeah, but I figure it's convenient. That way I don't have to balance it on. That way I don't have to try to balance it on the edge of the. I don't have to balance it on the edge of the frame while I'm trying to keep a camera on it. Okay, looks like the fan is on. I wish I could turn this around, but it's not going to happen. Oh my! There we go. Let's pick this up and let's bring this where the action is. The HDMI cable can only be. This is the longest HDMI cable that you can get that's on spec. It's 15. It's I think 5 meters, give or take. And it's not very wide. So don't worry, we'll be building stuff before you know it. focus up, move the light. There we go. So, as you can see, looks like our hot end cooling fan is working. We're at 170 degrees. I'm not seeing anything smoke. I'm not seeing anything on fire. Hopefully nothing should melt either. I have annealed all of the carbon fiber nylon parts, like basically all the black parts here. I have, I've annealed them in an oven for a couple hours at 275 Fahrenheit. Don't know what that is in Celsius. But yeah, that should improve its temperature deflection by, basically it shouldn't soften up until it hits in the neighborhood of, I think, it shouldn't soften up until it's nearly 300 Celsius. Yeah, heat deflection is generally around, or hang on a second. Heat deflection generally starts, I think, around 220, 200 something on nylon, and annealing it raises that by about 40 Celsius. So this thing should be able to take some seriously hot temperatures. Suicide NZ, Suicides NL says, what kind of chamber temperatures do you expect? I probably shouldn't have said your name out loud, I just realized. Do you expect to reach? There's not really a reason to ever have a chamber hotter than 100 Celsius. 100 Celsius is about as hot as you want, no matter what you plan on printing. There are some that you can print at a higher temperature, but I don't think it's... We'll see if it's necessary. I kind of doubt it. This is a small model, so I'm not as much worried about warping. Folks are suggesting a lot of very expensive camera equipment. If you'd like to see me upgrade my equipment, feel free to super chat. I really appreciate it. All right, we're smelling some smells, but that's normal. Let's see. We should expect to smell some smells. There's still like machining oil and other residues. None of these parts have been heated up before. So we're starting our timer. We'll let this thing run for a minute. I'm going to get my nose in there and see if I notice anything getting a little too crispy. Doesn't look like it. Doesn't look like it. Looks like our coupler is done printing, so let's go ahead and collect that. Good use of our time. Man, it's hot as hell in here. I have like a full-size dehumidifier in there to keep the filament safe, and it makes it like 41, 42 Celsius in there. Let's see. Rene says the steppers are rated for 80 Celsius and the rails are intended for 90. So, yeah, we're not gonna raise it that hot. On top of that, like, it's only gonna be heated by the bed, right? It's only gonna be heated by the bed and the the nozzles. So, yeah, we shouldn't have to raise it. We shouldn't have to raise it that high very often. But look, we'll see. We'll see. Hopefully this thing should be able to print, hopefully this thing should be able to keep it together long enough to, print a benchy. Benchy's around 3 hours, give or take. So, yeah. Oh, he says pre-greased. Okay. That might not be a bad idea to strip off the grease and replace it with a higher temperature. But, yeah, part of the fun. So let's see what happens. We're probably going to want to drill this out. Let's do that while we let this do its thing. We got our drills. We got our drill itself. All right. Let's see. What fractional imperial is closest to 4 millimeters? So let's see. 1/8 is around 3. So let's try 3/16. It's going to be probably a little wide. Yeah, it's a bit wide. Let's try 11/64. See where that takes us. Speed benchy. We can try. This printer is much faster. I mean, this is never going to be the fastest printer because the Toolchanger itself adds a lot of mass. So it's never going to be the fastest printer, but it could be at the very least faster than. Could at the very least be faster than my Prussias, which are already fairly zippy. I don't know. High-speed printing just. I think it increases the odds of failure a little too much. Like, if it doubles your print speed, but it causes every other print to fail, All right, so yeah, that bit was too big. That bit was too big. I made a boo-boo. All right, so we're gonna reopen. Fusion. We're going to make the holes a bit smaller, and I'm just going to reprint this. So stand by 1 sec. Let us reprint. CoreXY says, all the gods of engineering hearing imperial fractions makes my ears bleed. Them's the breaks. We are in America, and most of the tools that you can buy at a hardware store, there we go. Most of the tools you can buy at a hardware store are in imperial, because that's what we use for construction over here. Yep, that's what we use for construction. Okay, so that's about a minute. I think that's close enough. This is close enough to a minute that I'm satisfied. So let's walk around all this debris and try not to ruin everything. Try not to step on something and bash my skull open on the razor sharp corners of the Toolchanger, which totally haven't, nearly broken my kneecaps like 6 times so far. And let's get tightening. So I'm going to gently grip the heater block so it doesn't wiggle around. And yeah, we don't want this to be too tight. We do want it tight. So it's much looser. It's much looser when it's hot, because the metal changes shape. Alright, so let's orient this correctly, and let's snug this in nice and snug. Okay, very nice. So, will parking a hot tool cause us to have some problems? CoreXY, thanks a lot for the the GBP. Here, starting a fund for importing tools from Europe. I like European tools. I'd like European tools. Here in America, there are still some manufacturers that make some kick-ass tools, but all right, let's put this guy away. There's still some manufacturers that make some kick-ass tools, but a lot of them are hot garbage. Okay, let's cool this back down. Rene apologized to me over on Discord. Don't worry about it; it's part of the fun. People like to see the follies and the successes. They like to see the upsides and the downsides. So I just realized that we probably want to have this window. Let's copy this. Copy. And we probably want to have that over here. Alright, there we go. Awesome. Alright, so standby temperature is set to 0. So when I dock this, it should cool down. So let's see. And let's just verify the temperature should fall. It looks like it's falling. Okay, awesome. So, all right, we've tested both of those. Felix, thank you so much for the very, very generous super chat. Thank you so much. Thank you so much for this. Yeah, the Space Mouse was already more than enough, but thank you so much. Felix says, find a metric drill set for your toolkit. Keep at it. Best stream quality so far. Thank you very much. We try. Thank you so much. I really appreciate it. The donation is very generous. It's going to go a long way to helping us deck out the workshop. Thank you so much. I really appreciate it. All right. Cool. So it looks like this part. Thank you so much, by the way. That's a very generous donation. You've been a real help for supporting the channel. Let's move on to our next tool. Come on, pick it up. Oh, nice and sturdy. All right, cool. Let's move this back. Let's see. Is this? Ooh. All right, very cool. So let's move on to this guy. TKM, thanks so much for the PLN, Polish I don't know. Cameras are essential. Well, thank you very much for the donation. So it's very generous. I really appreciate it. Cameras are an essential maker equipment, aren't they? They sure are. Yeah, they sure are. I have my. I am pushing these C922s to the very edge. Oh, Zloty. Why is it? Does it start with an N though? Yeah. Thank you so much for the Polish Zloty. Brooke's mother's side of the family is all from Poland. We really got to go up and visit sometime. Thank you so much. It's a super generous contribution. I really appreciate it. Thank you so much. That's super generous. You guys have been great. You guys and gals have been great today. I really appreciate it. Let's turn up the heat. 285. Go. I'm going to turn the standby temperature back down to 0. Just so in case when we're testing later, I don't burn the living hell out of myself. All right. So let's see. When this thing reaches 70 Celsius, this fan should turn on. Right now it's 50. This is heating up really fast. 60. 285 is about as hot as we ever want to take this. This actually seems very, very hot. But this is intense. All right, so this should turn on. Yes, it turned on. Awesome. So it looks like these instructions were written for an E3D V6, which has even less metal in it than the Hemera. So this should be safe. All right, very nice. Connor Edwards says, "Stop over in the UK on the way over." Yeah, I'd love to spend some time in the UK. We had we expected to. So we had a layover in. Felix says, "What voltage is the printer? 24 or 12?" It's 24 volts. It's a pretty beefy printer. We had a layover on our way back from Israel. Or way back from Paris. I forget what leg of the journey it was in. Anyways, yeah, we had a layover in Heathrow, and I really wanted to it's right in the city center, and the layover was supposed to be really long. It was supposed to be like 3 hours or 4 hours or something. So I was hoping we'd get to at least grab some food, but our flight arrived late, and it was a mad dash. This heats up very fast. I can see why they picked 24 volts for this, because when we're switching tools, you want the thing to be able to change temperatures very, very rapidly. So, yeah, but thanks a lot for the generous donations. Folks have really gone above and beyond today. We're going to let this thing hit 285, and then we're going to let the heat soak in a little bit and tighten that up. These are using brass nozzles. These are using brass nozzles. These two in the center are just vanilla direct drive Hemeras. Nothing, no modifications, no fancy stuff at all. Just, all right. I upgraded the filament. I upgraded the part cooling fan, but that has no effect on the. That has no bearing on the extruder itself. That's purely to improve the performance of the print. Those two are for multi-material prints. These are going to let us use special support filaments and all that other good stuff. Suicides NL asks a question that I've really been thinking about. Considering going for a mosquito or dragon style hot end for easier nozzle swapping. With a printer like this, that shouldn't be necessary. The Volcano has a 0.8 millimeter nozzle. The Volcano has 0.6. The liquid cooled one, most of the time, it's probably going to run with a 0.8 or smaller. And basically, we should never have to swap nozzles on this printer, because we should already have our loadout set. That said, I would love to upgrade a Prusa with a Mosquito. So, for folks who've never heard of it, the Mosquito is. Oh, there's some funny comments. I gotta stop looking at it. So, for anyone who doesn't know, the Mosquito is an ultra lightweight hot end with a really clever system for rapidly swapping nozzles. The way I see it, the main advantage of the Mosquito is the weight. So if I were going to build a Mosquito 3D printer, I would want to get that thing on a printer that's already very lightweight and moves quickly. I feel like a lot of the upside of the Mosquito would be neutralized on this guy because of how intrinsically heavy the the receiver tool changer assembly is. So I'd love to get that like on a Prusa, or maybe even on honestly, like maybe something even lighter weight, like I don't know, maybe I remember back in the day the Lulzbot printers had both very lightweight lightweight extruders and CoreXY, like with all the belts and stuff. You know, it'd be even cooler though. Putting it on a Delta printer, a Mosquito on a Delta printer would be sick. That'd be sick. That'd be fast as heck. Oh man, that'd be so fast. Oh, that'd be great. Poggerino, the Voron. We gotta look. That's what I'll do while we're waiting for the next nozzle to heat up. Well, let's look into this Voron and see what all the fuss is about. All right, this has been hot for a couple of minutes. I think we can leave it heating up long enough to say that today's stream is sponsored by Things. Whether you have a Voron V0 or a Delta printer or any 3D tool changer or Prusa, no matter how silly your printer is and no matter how new you are, Things has got you covered. If you're making any, it doesn't even have to be an STL. If you're making models for any reason you want to share them, Things makes it super easy. You can upload your model in only a few clicks. It's super simple. If you want to find models, even if they're not on Things, you can still go ahead and search Things for them. If they are on Things, you get to visualize it in advance. It now is a versioning system, so there's no more confusion over whether you have the right version of a part for a given model. And it lets you attach licenses to individual parts, so there's never any confusion about what people can and can't do. Yeah, great for beginners and great for experts. Use the link in the description. Tell them I sent you. Make us look really, really good with our sponsors. Thanks lots of Things for supporting the channel, and thanks to you for using it. Things has been doing really well. A lot of folks have been finding out about it from our streams, and they've been really overjoyed. It's really great to see more people, especially if you've already done the models. You upload it to another site. It's super. Like, getting on Things is super easy, and it means it's going to be more accessible. Like, your open hardware is going to be more accessible to more people. So yeah, things.com. Use the link in the description. Thanks a lot to Things for making this happen. Silicon Slick, thanks a lot for the Aussie bucks. He says Silicon Slick 69, the sex number. 3D printing with butter when? I think butter's got to be one of the materials that's like least conducive to 3D printing. Like, the transition temperature of butter is going to be like 4 degrees. So let's clamp this in. This is so much easier. Also, it's very easy to change the nozzles here. This is so much easier than the Prusa. Alright. This one looks like it was already quite tight. So, snug it up. Very nice. Alright. Cool. So, let's, So, this is normal, apparently. Oops, let's get back here. Alright, so this is saying, error. Heater 3 fault, temperature excursion exceeded 15, target's 285, actual is 260. That's normal. That is caused by... Oh, now it's... Yeah, alright. Hang on a sec. So let's go back to... How do I clear the fault? I don't know how to do that. The manual warned that this is normal. Let's see if we can do this. The manual warned that was normal, but I don't know how to clear the fault. That's weird. Let's dock the tool and see what happens. All right. Cool. All right, we docked it. You're gonna have to trust me on this. It's not the thermo. We haven't installed the thermocouple yet. It's still just the thermistor. So let's try switching over to tool 1. I don't think this is going to pick up properly, though. Oh, hey, look who's in the chat. Voron Design. Thanks a lot for the super chat. Here's something towards your Voron fund. Thank you very much. It's always cool to see some Beetlejuicing going on. It's always good to see some Beetlejuicing. I really appreciate it. That's what we'll do after this. We'll check those printers out because I'm really curious. All right. we're having trouble. Thank you so much for the super chat. We're going to check those printers out in a sec. I was having trouble with Tool 1 picking up properly. So let's see what happens. I'm gonna. Yeah, it's not working. It's not engaging properly. See, it looks like it's picked up, but it's not. Yeah, I was having trouble getting that to engage properly. Okay, Rene says that Command M 562 with no parameters will clear a fault on all heaters. So we'll check that out. We'll check that out in a sec. We're gonna rehome the printer. Yeah, this is yeah. We'll spend a few minutes messing around with this. Oh my! We have a lot of people asking about, does the reservoir come stock in the printer? A lot of folks asking about the specifics. Not only does the pump and reservoir and all that stuff, not only does that not come with the printer, I believe I'm the first person to ever connect. I'm fairly sure I'm the first person to ever connect a Titan Aqua to a Toolchanger, because I couldn't find a bracket for it. Right? I couldn't find any way to actually mount it to the receiver, so I had to do that all from scratch. There were no instructions on how to mount this stuff to the side. I had to make my own bracket. I had to do a lot of 3D. I had to do a lot of design to get this to work. So no, this is an aftermarket kit designed to work with any printer, and I had to actually adapt it myself. So yeah, I don't really know what's going on with the plate. I think the easiest thing to do here. Rene says show a real close up of the T1 pickup so we can see what's going on. All right, Rene, all right. I'm going to move the camera over. We'll see. It's not engaging properly. It's not. You'll see. I think it's either misaligned a tiny bit, or I have to push the ball bearings further in. Let's switch over here. So you can see that there are these ball bearings that help it align. And I had a problem with a few of these plates. Ball bearings were not pushed in. They weren't seated all the way at the factory. So yeah, they weren't seated all the way at the factory. So the coupler couldn't get in far enough to engage. The tolerances here are very tight. So here, let's pull out a little bit to guarantee that we can see the phenomenon. And here we go. So this is the drop-off routine. You can see that the alignment is fine. It dropped off fine, but here, see. Oh, now it works. Yeah, it wasn't working before. Let's see. Yeah, it wasn't working before. Yeah, you see that right there where it caught? The gears caught a tiny bit. So now when we unload it, it might jam. Yeah, can't see it from this side, but now the Toolchanger, now the coupler is always now the coupler is a little jammed up. So we're going to rehome the coupler, and we'll try it again. It sometimes works, it sometimes doesn't. It's really weird. The mechanism is very clever. The tolerances on it the working tolerances are very tight. So what I'm guessing is that it's going to be tricky to get it going in the first place, but once we have it once we have everything lined up and configured correctly, Rene says the X isn't aligned properly. It looks like that's totally possible. Once we have this set up properly, I think it should be very reliable. So let's see. That could be possible. That could be why. Could be what's not going on there. So first I'm gonna home the system, and then I will. Let's see. I'm gonna open up. I'm gonna duplicate this tab, and I'm gonna open up the script that homes it, so we can. I'm going to open up the pickup script so that we can get our coordinates, and then we'll just do it manually, so we can see what's going on. Does it think it's carrying a tool? It does not think it's carrying a tool. Awesome. Silicon Slick, thanks a lot for the Aussie buck. I really appreciate it. Every little bit helps. Let's turn the camera a little bit. Actually, let's turn the camera a little this way so we can more easily see what's going on. I wish I had more of these so we could. wish we had more of these so I could get an overhead view as well. I think that would be pretty helpful. All right, so we're going to open up our system macros. The one we care about right here is tpree1.g, which is the script that runs basically before the tool change. This is what actually picks up the tool. So yeah, we're moving to this location. So yeah, let's open up our console and let's send some codes. So this first one here moves the. Let's see. This first one here moves the receiver to be almost in position. Let's. So let's run that. I don't know any of the. I don't know G code off the top of my head. All right. So that's almost lined up, and I guess it does. I don't know. Here, let's just zoom. Let's just zoom in. So it looks fairly close. The angle does make it awkward, doesn't it? Yeah, the angle does make it kind of awkward. So let's unhook the camera and let's see if we can do this by hand. Pardon the shaky cam. The Blackmagic doesn't have the best stabilization. But here, here. So it does look like it's a tiny bit off, doesn't it? And we homed this, so this shouldn't be the case. So let's shift this over. Like, you think it's an entire millimeter, or you think? Oh, geez, it's not helping, is it? Millimeter, a half a millimeter. Let's try a half, and we'll take it from there. Let's hook this back into the tripod so that everyone can not be nauseous. And now it's drooping because it's not locked in all the way. All right, there we go. Downside of having downside of having carpet in the studio room. Focus. Beautiful. All right, so let's try moving this over a tiny bit. I think this will do it. Yep. And I'm gonna eyeball it. That looks much closer to being lined up. Rene says move closer first. All right. So let's do so. We're gonna move. Let's see. This is moving 0.1 millimeters at a time. Ooching closer. Let's double check. That looks pretty lined up. That looks about as close as I can get. I mean, maybe we can bring it over a fraction of a millimeter. Let's see. That's looking pretty close. Maybe even I think we might even have gone a little too far. Yeah, I said this would be finicky. This is where the this is where we ended up. All right, so we're going to use the position of, but don't we want to try? So Renee's saying you need to use the position of T post 1 or T pre 1. So don't we want to try moving the X over a little bit? I think it's a bit misaligned in the X axis. 83.4. So here's. Let's see. So we're gonna put this in here. All right. Well, let's see. I'm gonna move back. Let's back up a bit. And all right. So here's the position from the script as requested. There we go. Oh, do you think we should loosen up the dock and just like get the dock into place? Maybe that's what we should be going for. That's what I'm thinking. Yeah. So it's now in position. Yeah. So I'm thinking we should maybe loosen up the dock and yeah. and align that. All right, so the tool shouldn't move at all. Let's see. So it's moving a little bit. Let's let's move the dock inwards. It's funny. The other it's using the same y. It's using the same y value as. Let's go over here. It's using the same y value as the other docks, which is really weird. It doesn't look like it's drooping, but it's definitely wiggling. So let's loosen up the dock and try to push that further into place. So, yeah, there's a little bit of wiggle room on the dock. No, this is as far as it goes. Yep, that's as far as it goes. So, yeah, looks like we'll just have to adjust the script. I don't think it's moving far enough in on the Y. That's weird. Why is this one slightly narrower than the others? Or is it just the nature of a printer made of plastic, or rather a printer with plastic parts? Come on, screw that in there. All right. So yeah, I think we need to move it in a little bit. Let's hold this to move back. So you think it was colliding while we were moving it in? All right, so let's try that again. Moved a tiny bit. Yeah, I think it's misaligned in the x-axis. Let's. All right, so I'm gonna home it again, and we're gonna. Oh, you can't see me. We're gonna home it again, and then I will try to. I'll do it again and change it. I think we're a little off in the x-axis. Suicide Zanel says, "Is it possible the axis isn't perpendicular? It should be pretty tight. I squared this all up with. I squared this all up before doing all this stuff. So let's see. All right, so 226. Let's head over to 215. Moving. It's moving. It's just going slowly. Alrighty. So yeah, it looks like we're off. We're off the axis a tiny bit. So let's nudge this over a little bit and double check. No, we overshot. We went too far. Rene thinks the tool might not be hanging level on the dock. I suppose it's possible. I don't have. Everything should be pretty tight though. Yeah, I mean nothing's budging, so I don't know what I could like. I think they all. I mean, the dock isn't a perfectly tight fit, but let's try this first. So let's see. All right, that's looking pretty close. I think I'm going to nudge it over a tiny bit more. Nope, not necessary. All right, let's try picking this. Let's try picking this up again, using the different. Yeah, using. Let's see. I'm gonna try picking this up again using the new dimensions. 3.1, and let's move out to the same. I love that you can edit it locally. I don't have to like unplug an SD card and all that crap. All right, let's give this a shot. I'm gonna back this out, and let's try to load it again. Here we go. Oh, there we go. Yeah, it looks like we're just off in the we're just off in the X direction. Cool. So let's. All right. So we didn't edit this in every location. Yep, there we go. Okay. And we also need to update this guy here. This is the script that returns it to its dock. I wish there was a way to do variables, but RepRap doesn't accept variables in G code. So let's unload this and just make sure everything works fine. Don't fall off, please. Very nice. Let's pick it up a couple more times. Isn't that cool? This system's cool as heck. Oh, that's awesome. Oh, that's awesome. Pardon the dead air. I'm just in awe at this thing. So let's home. So I'm going to rehome the system. And we're going to try it one more time just to make sure that, you know, like if while we were dialing that in, if it skipped a step, then we don't want that to get baked into our scripts, because then our scripts will be permanently misaligned. So yeah, come on, easy does it. Very nice. I have to be careful not to destroy the Z-axis switch, because apparently it's very easy to break, and I ordered replacements preemptively, but they haven't shown up yet. So let's see. Oh, perfect. Perfect. And the dock and the pickup. Ah, beautiful. All right, awesome. So, yeah, let's, yeah. All right, so let's hot tighten this one now that, yeah, let's hot tighten this one now that it's working. Oh boy, I'm actually going to switch us over to the other camera while I do this, because I don't want to make anyone nauseous. I know I keep forgetting, but you know. Every time we prevent people from getting nauseous, it is a win. Let's see. All right, and let's move this in a little closer, make it a little easier to work on. Very nice. Sandra Wolf asks, "Are you building a 3D printer from scratch or a kit?" It's a kit, but it involves some parts from scratch. You have to. It is a kit, but you have to design some of the parts yourself. It's not fully turnkey. It's don't be wrong. It's this is a really high quality kit using really high quality parts, but it definitely expects the user to put in some work. You gotta suffer for your Toolchanger. Get in there. Get our exposure right. Okay. And let's get hot. 285 go. Let's see. Temperature is rising. Is it? Yep, temperature is rising. Very nice. Suicide Sentinel asks, Zack, is that a special ESD safe carpet? No, it isn't. But the workbench is static safe. It's grounded at both sides. The printer is also grounded. So yeah, all the work stuff is properly grounded. Arrow Raider says literally days of assembly required here. In my case, it was weeks. But then again, like, I've never really built a 3D printer like this before. Like, if you've built RepRaps and other open source printers, you're probably going to be right at home. So some folks are asking, like, what's the point of having a Toolchanger on a 3D printer? Like, what's the point of having all these? What's the point of having all these detachable heads? The first is that it's a really elegant solution for multi-material printing, because yeah, it's really good solution for multi-material printing. A multi-material unit, or like a filament exchanger, has, like, the main problem with that is it's very slow. You have to unload the filament, you gotta load in new filament, you have to purge it, and then you get to do your thing, and it increases the chances something jams. Not optimal. you can put 2 extruders on the same printer, but that is multiplying how heavy the... it's not really practical to do a direct drive, because then you have just two steppers and tons of crap. So it's not always the best solution either. On top of that, like, get some practical when you're trying to print with more than 2 materials. You can use a filament splicing system like the palette, but that doesn't work very well when they're different materials. For instance, if you're using you're printing PLA with PVA to support it, it can't really splice those together. So it just gives us a ton of options. On top of that, it lets us do really exotic stuff, like have different nozzle sizes. Like you have to modify this. You have to mess with the slicers for this. But we should be able to use, for instance, a 0.8mm nozzle for support material, so we can run our supports faster. It lets us put in non-3D printer tools. Like, pardon me. Like we could for one of them we could replace it with a CNC. So yeah, we could add like a tiny CNC router instead of an extruder, and we could replace one of them with a laser cutter. For instance, we could rip the laser diode off of my laser cutter and make a thing for it. It's so cool. It also gives us the ability, things like water cooling. That has its use, but it's not necessarily something you want for every print, because it's it makes it much heavier. Yeah, so it just gives us infinite options, and at any point, like if we don't like one of the extruders, we can just unplug all the cables, snip the zip ties, and swap it out. Maybe I'll modify it later to make the entire extruder easier to replace. It's pretty sick. So let's see, we're holding at 285. Let's let this last for a while. And, oh, hey, it looks like I have been mentioned on Discord a few times. It doesn't look like it's from Brooke. Those are the ones I care about. All right, let's take a look at these Voron printers. I've never really heard of them. So let's see, Voron V0. Let's see, the little CoreXY space shuttle. This is an interesting looking printer. There's no gallery. Where do I take a look at it? In the configurator. New build. Give me the full thing. Alright, that's not what I want either. How do I get a good look at the thing? Oh, the manual's a download. Oh, that's pretty sick looking. That looks pretty sick. It says, we build space shuttles with gardening tools so anyone can have a space shuttle of their own. Space shuttles are cool. Let's see, so we're printing this. Alright, so it looks like this is a heavily... so it looks like you buy a hardware kit from Voron and you print the parts yourself. So that's pretty interesting. So this is a CoreXY printer. And I'm guessing that they can be modified to be very fast. This might be the printer I was thinking about. It's pretty sick. Pretty sick! That's a pretty cool looking printer. I think if I keep getting printers, already I have more printers than I can store. So I'll have to figure something out. Maybe I'll give away the Viper. It's pretty cool. It looks like it's fully enclosed too. I like enclosed printers because it's easier to convert an enclosed printer to a... it's easier to convert an enclosed printer to an open frame printer than it is to do it the opposite way. Voron Design says, we're not a company, we don't sell anything, it's all open source. This is a very clean open source project. This is how I would like to make my instructions for my open source projects. Yeah, I mean, hope somebody took a lot of time on this. Hopefully at least have folks buying parts kits to pay for the hosting and to reimburse the designers. That's pretty cool. This is a nice, tidy looking printer. It's got a slot for a Raspberry Pi 3 on the back. Very nice. Oh, this is a cool looking printer. Yeah, it looks awfully sick. Zack Richard asks a question that I have dealt with many a time. He asks, any tips for cleaning a nozzle completely covered in filament from a failed print? This is a very cool question. Oh, by the way, this Voron thing looks pretty sick. I'm gonna look into this more. Later. So the first thing you have to do is heat up your extruder. Bring it up to a little hotter than you would to print that material, and then gently. And when I say gently, I mean delicately, gently, like you're stroking a puppy. Gently try to remove the filament. Hopefully the blob. Hopefully the blob comes off. If you're lucky, then it's only on the extruder, or it's only on the heater block, and it'll come off. Yeah, let it heat up for a few minutes, and then hopefully that's all it takes. If not, grab a hair dryer. I'm assuming it's PLA. There we go. I'm assuming it's PLA. So grab a hair dryer and set the hair dryer to the highest temperature that it has. Usually they just have high and low. Set it to high, and blast the bejesus out of it. Yeah, blast the bejesus out of it. Yeah, I have a blob. I have a blob here. Yeah, I should have it handy. Oh, look at this blob. Look at this thing. Look at this friggin' blob. This is a blob that I pulled off one of my Prussias. It's rather large, as you can see. So hit it with a hair dryer. Hopefully that softens it up enough that you can remove it. If not, at that point, keep the hair dryer handy. Disassemble the extruder. Right, heat up the blob. Remove as much of the plastic as you can. Hopefully, you can get the entire hot end assembly out. At that point, cool it off, obviously. And once it's removed, then you can really blast it and get the blob off. Whatever it is, after you remove the blob, you should give everything a big old scrub with a brass brush to remove any residue, and give everything a big old brush, and make sure. And then, so this is supposed to happen right. This is supposed to happen right here. Scrub off all the excess, and then go back and recalibrate everything carefully. Check every part. Make sure nothing is warped. It's likely that some stuff took damage. Make sure no wires got bent out of shape. Just give it a full once over, full look. Alright, let's try to dock. Let's see if we can dock our tool. Dock. Be easy. Alright, and last but not least, we got the Titan. So anyways, that's how I got this off. What I didn't realize is that when I removed this giant blob, I wasn't diligent enough in making sure that nothing was broken. So I ended up warping a few of the parts in the Prusia in the process, and I didn't realize this till I think months later. It took months to realize that. In the meantime, the Pinda probe was shifting around, so I kept having to recalibrate it every once in a while. A layer would shift. When you're removing the blobs, you have to be J3 is totally correct. When removing the blobs, be careful about the thermistor wires, and I say all the wires. Yeah, ideally, if you know where the wires are, start on that side and carefully remove that filament. That's the most likely thing that'll happen. If you are using a print, alright, one final thing. If you're using a printer like the Replicator 2, that basically has a hot end wrapped in some sort of insulating material. The Replicator uses ceramic fiberglass tape. You got to get that. You got to throw that out. It's no longer useful because the air voids that make it insulate have been filled with plastic. So there you go. All right, let's see if this picks up. All right, so it looks like I'm not seeing any drips or anything. Let's see if this picks up the Titan tool. Looks good. I need to change the speed on this. I want it to move slower with the Titan tool. That's it's working. It's working, folks. Check that out. You see how the liquid cooling tubes get pulled along? Yeah. Isn't that good? I love that. I love it. Let's try to move this into position. There we go. All right. So yeah, this is the copper. This is a nickel-plated copper. Oh, we can't hot tighten it until it's hot, can we? Oig Vault 285 go. Yeah. 285. Okay, so while we heat this up, let me check on our packages. UPS. So this is, I think this is the 3D printer stuff. Hasn't been delivered yet. Did I? Let's see. Okay, let's see where the enclosure is at. Hopefully it's on. Hasn't arrived yet. Still out for delivery. All right, and let's double check the stuff from Printed Solid. That's the thermocouples and thermocouple drivers. I think I might have also ordered a filament sample. Yes, I did. I ordered 2 kick-ass filament samples. These episodes are very. This particular episode is very expensive. All right, neither of them have been shipped, so it looks like the stuff that got dropped off is probably unrelated things for a future episode from Amazon.com. Essen Jeff Bezos's D. That's wait, huh? So what? Wait a second. This didn't. Wait a second. What got delivered? Oh man. So what? Wait. What got delivered? I know I have a package, but I don't know where the. Oh my gosh. All right. It must be the filament. Let's see. Global. So I got a whole bunch of samples from Global Film FSD. Terrible URL. Terrible. Anyone from Global FSD is listening in. Change your brand. Global Filament Sample Department. They have like tons of filament. I cleaned them out. I got like dozens of samples of filament from Global FSD. All right, so it looks like it's out of Europe. It's in America. And wait, this hasn't been delivered. What the hell got dropped off? The hell got delivered? I'm so confused. I don't know what got delivered. Okay. All right. I don't know what's there. Oh yeah, Reagan. Thanks for the super chat. Thanks so much for the super chat. I really appreciate it. Thanks for supporting the channel. Oh right, the fan. We probably the pump is pumping. Yeah, the pump is still pumping. So passive cooling should be enough for now. Yes, we finally got a PO box. Voidstar Lab finally has a PO box. I forgot where I put the sheet of paper with the PO box on it, but yeah, we have a PO box, so we'll now be able to take your crap for mailbag. We'll be able to give out a public address in a different city that we can safely receive all kinds of stuff at. So we'll be able to do mailbags. So if there's anything you'd like to appear on Voidstar Lab, you now have an opportunity to show it off. Let's do our hot tightening. It's just so hot. Yes. So hot. Right. Our layout here is a little bit different because it's pointing the opposite direction. This is closer to what I'm used to on the Prusa, where the wires are getting in the way. So, jeez. The problem with the wires getting in the way is that I have wires in the way. Don't you hate when that happens? I gotta decide whether to put socks. I don't think this one would benefit from a sock. There we go, nice and snug. Let's see. Put this in place. Nice and snug. A little bit more. I should get a torque wrench. Few people have recommended that, and you are totally right. I should totally have a torque wrench. But I have changed the nozzle. Like, these all use the same torque as the Prusa because they all use the same heater blocks. So I have a feel for it. I have changed those nozzles like 100 times, but I should really get a torque wrench just in case. All right, looks like looks great. Looks like we're in business. So that all right. So we're done. Oh, I don't think I want that. I want that. There we go. So let's dock this tool. Dock. Yeah. So let's dock this. Please don't plummet to your death. I'm permanently scarred now because I'm just so. We had so many mishaps during calibration, during setup. All kinds of crazy crap happened. Okay, good. So we've hot tightened everything. Let's take another look at our. All right, so let's see. Remove. Yeah, we don't want to be. We could put socks on. I don't think it'll make a huge difference. Yeah. Okay. So let's see. Oh yeah, let's test the bed. I have never turned the bed on either. Where is our bed temperature? How do I do that? Oh hey, there we go. Bed. Let's bring up the bed to. It says 50 Celsius. I don't know why. So this. All right. Big difference between this printer and the Prusa. All right. We want to do the standby temperature here. Big difference between this and the Prusa is that this guy has a 120 volt AC bed. The bed is plugged straight into the wall. It's not no low DC voltage baloney. This thing is going straight to the mains. So it should heat up in like 4 seconds. Here we go. Let's see. There we go. Oh, look at that! Look how fast this thing is heating up. We're already at 35. We're already at 40. we're already at 45, and we are at 50. This heats up. Oh, it overshot. I probably have to tune the PID values. Yeah, because look at that. Look how I can't see that. You can't look at it, can you? Let's try to get. Yeah, look. How do I get a temperature chart? And look at that. It overshot it like crazy. Overshot it like crazy. Overshot in the other direction, or on the extruder too. So yeah. All right. What's that G code to clear these errors? And let's also switch this. Let's also switch this back to 0 before I burn the living hell out of myself. Let's not turn it to 500 Celsius. What's my G code to clear these errors? It was posted earlier and I didn't run it, and I really should. So let's scroll back and see what we got. Veldurk says that's why Zack is making these streams. He's suffering so others who can't find good documentation don't have to. Well, all of our streams are only available to. So our stream replays are available to patrons. So yeah, you can bookmark this. You will be able to access it later with a bookmark. But if you want to see all of our past streams, become a patron. Yeah, you gotta become a patron. It supports the channel. It supports the channel, and it lets you get access to all the streams. I went too far. Oh, there we go. M562. M562. Go. There we go. Our faults have been cleared. Order has been restored to the universe. Excellent. It's cooling down a lot. The bed is cooling down much slower than it's heating up. So we have a little bit of an asymmetry at play. Very, very nice. Bfinger just pointed out that this isn't Octoprint. No, it's not Octoprint. This is the web interface. This thing doesn't actually have a control panel of any kind, not even LCD. Like, literally, the only way to do anything on this bastard is through the web. So, maybe we should, like, set up a Raspberry Pi to, maybe we should set up a Raspberry Pi to do this, or to display this. Yeah, make life a little easier, or just staple a laptop to the side of it. Okay, so all right, so we've set up our tools. Next thing to do is, and this is the part that we're going to have lots of trouble with, is we need to set the offsets. Basically, we need to have it match the actual, like the coordinates inside like the printer's head, I guess, with the actual tip of the nozzle. And from my understanding, this is going to be a huge nightmare. This is RepRap. Some folks are asking what we're using here. This is RepRap. This is the newest version of it's newest version of the RepRap firmware, and this is the RepRap web interface dashboard. I think it's a RepRap Duet web dashboard. It's a DW something. Anyways, yes, that's what we're messing with here. So let's do the let's move on to the next step. Let's check our calibration. Calibrate. I keep forgetting all of our buttons. Calibrate your printer. Come on, do. I overshot it. Now it's taking up more of the screen because it's a different size. That makes sense. All right. Okay, back to commissioning. So we already have our glass bed in place. That heat up with the bed. That's nuts. It's nuts. So we home the machine. Click the auto bed compensation button. The tool head will probe several points on the bed and finish in the park position in front of the machine. So let's get ourselves a better angle on the action. Let's move this over here. So, yeah, I want everyone to see. I want everyone to see this. The webcam is not tall enough. It's not high up enough off the ground, so it's not going to do a great job of capturing this. But it's got auto bed leveling. I love it. I love auto bed leveling. It's my favorite kind. That was the worst part of the Fab Labs printers, is the having to level the bed. Never ended with the friggin' bed. All right, let's do this. Alrighty, where is our where? Click the auto bed compensation. Where's the auto bed compensation button? Anybody see an auto bed compensation button? Maybe it has to be full screen. Nope. Compensation and calibration, true bed leveling. Is that what we're doing for? Is that what we're doing here? Run mesh compensation. Is that it? Auto bed compensation. I guess it's mesh compensation. All right. Here we go. Oh, there it goes. Oh, look at it go. There we go. Mesh compensation. So I think this actually produces a pretty sweet, there we go. Yeah, I think this actually produces a pretty sweet like heat map of like the way the bed's laid out. And I'm looking forward to seeing that. Bear with me one sec. I got to hydrate. Go, go, go. It's only probing once each time. Prusa probes a bunch of times. Alright, looks like it's done. We got some numbers to look at. What do you say we check them out? Check them numbers. Height map. Oh, that is really at a bit of an angle, isn't it? Yeah, things could have shifted while we were assembling. So let's it's all right. Let's drop the bed a bit, and let's drop the bed, and let's get ourselves over there and tighten it up. Maybe we forgot we might have forgotten a washer or two. This has been a very long build, so I wouldn't be surprised. All right. So let's just double check. All right, we've got. Well, this is the wrong one, anyways. So let's see. We've got washer top and bottom, and inside as well. Washer. We got washer, and over here, washer. All right, so let's just tighten this down. So it looked like this side is too high. So let's focus there. Tighten all of this down a little bit more. That seems fine. Oh, this one's very. All right. This one. All right. It looks like we found our culprit. One of these screws was way too loose. Let's check the others as well. See? Oh, this one's too loose too. I guess I just didn't tighten up this corner. I must have just forgotten. And let's tighten this as well. I could use a little love. Yeah, give this thing a bit of tightening, and then we'll give that another shot. Yeah, I know. I'm not very fluent with G code. I haven't really spent a lot. Like, I haven't substantially worked with it for any of my projects. But look, first time for everything, right? Nice and tight. All right, let's push our clips in as well. I don't like these clips. They feel like they're right on the edge of falling out. Maybe I prepared them wrong. All right, let's do this again. Let's see how bad we are. We probably should heat the bed up before we do this, huh? The leaning bed of Pisa. Rene's ever the optimist says at least it's flat. Yes. If the glass bed is curved, you know things have gone terribly wrong. Dale asks, what printer is this? This is the E3D Toolchanger, or technically it's a motion system with the Toolchanger. Let's see, Rene says the tilt is coming from the bracket on the Z carriage where you mounted the cable chain. Alright, well let's see if that caused, there were 2 screws loose. So let's see if that had any effect. Looks like it's still pretty aggressively tilted. This is exaggerated a little bit. Yeah. So it doesn't have to be perfect, but we do want to make it. We do want to make it fairly close. Let's see. All right. So what do we do here? I guess we loosen up the. Oh, hey. There we go. So I'm guessing that we loosen up the point where. Yeah, there we go. So I'm guessing that we loosen up the screws in here that connect the bed to the Z, and give that a little tilt, a little tilty tilt. Or is it the screws that attach these 2 plates together? Is that what's going on? Let's first test for tightness. Seems tight. Seems tight as well. Maybe some of these are too tight. Yeah, they all feel tight. So let's see. Let's see. The tilt is coming from the bracket right in the Z carriage. All right. So let's see. Let's loosen this up a tiny bit. Just a bit. All right. Well, here's the question: like, which part? So there's this bracket that connects the bed. Basically, the bed is connected to a bracket, and that bracket is connected to the Z-axis. So, are we adjusting the screws that bind the bracket to the Z-axis, or the screws that attach the bed to that bracket? Let's see. Loosen. Well, which four screws? Let's see. The bracket right in the Z carriage remounted the cable chain. So yeah, but which? Yeah. So Rene, which? What are we adjusting? Are we adjusting the screws that connect the bed to that bracket, or the screws that connect that bracket to the Z axis? Yeah. Or does it matter? I guess. I'm not even sure if it would matter. Let's loosen up these guys. Let's see. All right. Yeah, this is the part that's going to be a little less fun. So, I understand. All right, and this needs to be dropped a tiny bit. All right. Let's tighten back up. Titan AE. Yep. Fortunately, streams have to serve double duty for, me building projects. So there are always going to be some boring parts. It's the nature of the game. Not every part of the project is exciting to watch. Fortunately, we don't build project. I don't have the money to have a Tony Stark style automated lab that does all of the work for me. All right. So I tilted it a tiny infinitesimal little bit. Oh, my sock is inside out. That is true. My sock is inside out. There we go. Order has been restored to the universe. And, alright, let's do this again. Once more with feeling. Let's see. Heat map or terrain map. Alright, let's do this again. Hopefully I didn't do it too far in the other direction. I've never actually looked at the mesh leveling data for either of my Prusa printers, so those might be way off too. Yeah. I might do that now. I don't actually know how well calibrated any of my printers are. I've never really taken dialing in my printers very seriously. Like as long as I can make prototypes, then it's good enough for me. So, yeah. So this is going pretty. It's going pretty good. Yeah, it's true. Renee's pointing out that we can hear the difference in the duration of the Z move. All right. So it looks like we've tightened this up. Yeah. All right. So it looks like we've tightened this up about halfway. We've gotten rid of about half the. Somehow it seems to have become curved. That's weird. Is that healthy? It looks like we've gone about halfway. So now it's time to do some science. Let's heat up the bed. What should we do, like 75? Let's heat up the bed, and then we'll do it again. Because I want to see how this changes. Yeah, let's is there a way to save this? Yeah. Alright, so this is, get a good look. This is what this looks like before heating. The curve has to be like an artifact. Let's see. So it looks like this is, looks like our highest point is 0.18 millimeters too high, and our lowest is it's about half a millimeter too low. So total variance is about 1 millimeter across the bed. So yeah, so this isn't terrible. This isn't too bad. I am curious. So let's see. So we got between 0.182 and 0.566, and yeah. So it looks like we're up to temperature. Man, this thing is really hot. Let's do it again. Let's do it again. Let's see what changes. I'm a little worried about melting the. Is it? It's not likely we're going to melt the probe, right? Yeah. The curve is. Renee's pointing out the curve is from the x-axis. The x-axis is bowed downwards. Glass is flat. All right, so it's the printer being slightly misaligned or curved, not the bed. But like, I forget as long as it's within a certain amount of tolerance, then we'll be able to. The software can compensate for it, and I think this is actually tight enough. I probably should have seen. Yeah, gentleman with the Russian name points out that you can save the heat map file. Yeah, so we can. Let's check this out. All right, so it looks. Let's see. So it looks like when it's heated up, it's shifted downwards about 20 microns. 20 microns, something like that. I think this is all right. I think this looks fine. Granted, I don't have a lot to compare it with, but I think this looks fine. What do you, Rene? What do you think? Should we? Let me actually blow this up. Jamie, pull that up. What do you think? Should we? Oh, that's not what I want at all. Make it bigger and biggin. Yeah. What do we want here? Should we loosen things up and? What do you think? Should we loosen this up and fix things, or are we good? Are we good enough to move on? I don't really know what to make of that. I should. Let's see. View the results. Mesh compensation is disabled until probing is completed. Let's see. Okay, so I'll edit the G code to make it do that automatically. What do we think? Okay, it's not fine. So we want to tilt it even more in. Let's see. All right, so we need to tilt it even more. All right. Yeah, true. I sincerely don't know what to make of. There we go. I sincerely don't know what to make of these numbers. So let's. I'll trust the expert. Let's loosen this up a little bit. And I'm guessing that we're trying to raise the other end by about half a millimeter. We're trying to raise the right side. I don't see how we'll be able to raise the z-axis, though. Like, how we'll be able to raise on the y-axis, though. But we'll see. All right, let's. I think I have to loosen this a little bit more. It's still too tight. Still too tight. Ah, I know this is terrifically exciting. Let's see. All right. Pull that up a little bit. Alrighty. Okay, that is pulled up. Let's tighten this down. Ah, jeez. I love these new hex keys. I am so happy I shelled out some ludicrous amount of money that would make Brooke divorce me to get this super fancy set of Wera brand hex keys. They are pure luxury. Let me tell you. Come on. Play nice. Being belligerent like our dog. The head of that screw is getting a little bit stripped out. Alright. And gonna give this one final tighten, and yeah, let's do this again. Again, like we're not gonna do this all day, right? Like, we're not going to do this all day. If this still causes, if this is still giving us trouble, if it's still giving us guff, then I will we'll just move this. Yeah. If this is still giving us guff, we'll just move on, and I'll pick this up after after the stream ends, because we want everything to be fun and interesting to watch. So the next thing to do here after this is done is to dial in the offset, and that's the part I'm really dreading. Yes. SP Roach recommends loosen slightly and apply hammer. Reagan asks, doesn't the creation of the bed level map make the printer adjust for the change? There's a limit to how much it can compensate. Let's see. I raised the... oh, did I raise it too far? I went too far in the other direction? What the heck? What's going on here? Why is what I raised the other side? What's going on? I'm confused. I am confused. This is the orientation, right? Like this is how it's set up, right? Like these are now pointed in the same direction, right? Like I didn't like it, or is this backwards? Is this like this? Well, because like I raised this part of the bed, like this part right here. Like I raised it visibly, like I saw it go up. So I don't know how it looks so similar. Now, says no origin is front. So this is the origin right here, right? So this is how it's lined up. Oh, I guess I could just. Giannis points out that I can just send it to 00 and find out. All right. Yeah, that's really weird. I don't know what happened there. Okay, so this is what we're seeing here. That's really weird. I don't know what went down. So let's move this guy around and. All right, let's time box this. In the next 10 minutes, we're going to move on from this. Regardless of how well calibrated this is, in 10 minutes, we'll move on to our next step. Because I know this is not the most entertaining thing to watch, and you folks are here. Are you not entertained? Let's see. And let's drop this a bit. All right, let's do this. Let's give this one more shot. Okay, so here's what we're going to do. I'm going to loosen this up a little bit. And then this part, we're going to raise it up, right? We're going to try to raise this up. We're going to try to knock this down. So, let's get under. Loose, just a little. Loosen up. A little loose. And a little loose. Well, that's not loosening. I think I'm starting to strip this one out. All right. All right, it's jiggling a little bit. All right. So I raised that end up a little bit. Let's tighten it down. Yeah. Knock it. Don't knock it till you try it. I guess I shouldn't try it till I knock it, right? Like it's kind of the opposite now. Ah. And last one. Come on. Come on, be nice. Be good. It's like we're dealing with our dog. Oh man, I gotta try to get that guy fostered. We'll deal with that in a bit. Too much stuff to advertise and announce. Oh man. Why? I don't have any spares of these screws. I'm gonna have to spend a fortune on McMaster again, aren't I? It's all stripped. Oh man, I think I blew it. It's supposed to have this special shape that makes it harder to strip screws, but it's still not perfect. This is bad. Come on. I think that's as good as I can get it. Yeah. Damn. Well, hopefully I have something to replace it with. All right. Let's give this a shot. Was it G29? Yeah, there we go. G29. Oh, we're gonna get it. We're gonna get it nice and satisfying. That's right. Reagan, thanks a lot for the super chat. This stream is sponsored by Things.com. This stream is indeed sponsored by Things.com. We'll shout them out in a little bit. Johannes points out, if it doesn't change again, your frame could be warped, making the x-axis tilt slightly. It's certainly possible. I built the frame like over a week ago, so it is possible that it's settled or I put pressure on, or maybe like when I whacked my knee into it for the 6th time, maybe when I whacked my knee in it the 6th time, it might have knocked things out of alignment. I guess it's totally possible. Oh my. Alrighty. So let's take a look. Yeah. It looks almost identical, maybe even. Yeah, it's basically the same. So I guess I guess I'm maybe it's the frame. Yeah, I'm sure I squared it up, but we've had, a lot could have happened. All right, what do we? Graham Turner says, jealous of my ability to work on this stuff without getting into cold sweats like I do. I think you spoke too soon. I'm definitely sweating. Yeah. 6 minutes more for tweaking. That's right. Hans Skimager asks, "Where's part 1 and 2?" So all of our streams are available for patrons. Patrons can watch all of our stream archives. But I've been extra generous. So I've been extra generous, and if you go on our Discord and you check out live streams, you'll find links to both of those. So if you're not a member of our Discord, now is an excellent time. You know what? We're going to cut out early. Let's stop here, or let's stop trying to level it, and let's move on. After this is done, I'll go back and try to square everything up. So, okay. All right. First print. I think this is skipping a part, isn't it? Yeah, we can't just go straight to printing. We have to adjust our offset. Yeah, time boxing is very important. When you know something's going on too long, you have to pick a point where you're going to abandon it and move on. It's part of the fine. Is this what we're looking for? Fine-tune Z offsets. Grab a copy of it. So this is a calibration. Here's what it'll do. Heat the bed and nozzle. Park the nozzle. Rehome Z. Oh, so this is... I don't know what that is. First print. First print is just with one tool, no offsets needed. Well, we got to set that up anyways if we're going to do multi-material. Or, yeah. So Rene, what do you think? Should we just go straight to running this set Z offset script? Are we gonna actually print? Are we actually print? Are we printing? What do you think? Are we actually gonna do a little printing? Yeah. Time boxing is a term from Scrum. I think it's Scrum, or it's lean or aggressive. It's one of those gimmicky aggressive programming things. I didn't come up with it. Yeah. So let's see. Let's grab this while we're. No, do set the offset, but not with that step you had. I'm confused. I'm gonna need you to. Let's see. Let's download this. Rene, I'm gonna need you to rephrase that. Let's see. So looks like we got some various G codes here. Rene says I need to do a paper method. All right, where are the instructions? I will follow them. The other thing is how to set the whatchamacallit. Here, let's pull over. Let's get back to here, and let's open up our scripts. So we've got here in the config. We'll make this a little easier for everyone to read. So we've got these guys here. Where are they? Let's open this up. Here we go. Yeah, we've got these. So, we got these, and these have to get set. Oh, that's not what I wanted at all. Yeah, this is the part where... Yeah, this is the part I've been worried about for the last week. So yeah, this stuff right here is setting the tool offset. So is this what we have to do first? Because these are just estimates. Yeah, we've got some Hemera tools. Let's see, Volcano tool. I'm guessing. Yeah, like I honestly don't. So these are offsets, but I don't know how to get the X and Y offsets correct. Yeah. So, yeah, I don't really know how to set these. This is just trial and error. Yeah. Or you just set to the tool offset instruction and adjust the measurement with paper. So, yeah, the Z I think we dial in with paper, but it's the X and Y that I'm a little worried about. Because this is, like, the plate is graduated, but I don't know if those are real coordinates. Rene says, I did 3 videos about this step, it's over 2 hours. I don't think we're gonna watch those. It's too much for the chat to explain. So then I guess I made a boo-boo. I wish that was mentioned somewhere in the instructions, so I could have prepared for that last night. Let's see, we could make it up as we go along. Let's do some. All right, let's get back to PID tuning. Let's see. All right. Pick a tool and do the paper method. All right, Rene. The thing to remember is I've never used a printer like this before. I've used MakerBots, I've used Ultimakers, and I've used Prussias, and all those have a script in the. Like, all those have, like, a script, like, in the printer itself that runs off an LCD screen that, that walks through the process. So I don't know how to do this. That's right, Zack, that's right, folks. Zack's not omniscient. I know. Okay, so let's look this up. Duet, web, control, paper leveling, I guess? Calibration? Let's see. Static test of the Z probe. Alright, so we got that. Calibrate the Z probe trigger height. Is that what we want? I don't think that's what we want. Measuring the probe XY offset. The firmware needs to know the position of the probe in relation to the tool, in most cases the nozzle tip. If the probe uses the tip, the offsets are X0 and Y0. If you have CAD files for your probe mount, you may already know the X and Y offset. Ooh. We could do that. We could open up the Toolchanger. That'll help with the Titan tool. That'll help with the Titan tool, but not the Hemera tools. Here's the easy way to measure the offset. Tape down a piece of paper on the bed, bring the nozzle down to the surface, and lower it until it depresses into the paper, making a small impression. Mark the impression. Now jog X and Y until the probe is directly over the spot where the nozzle was. Take the amount you jogged as your X and Y offset to use in G31. Now, this is going to cause another problem in that there's already an offset applied in... There's already an offset being applied in the script. Let's see. Unfortunately, let's see. So, let's see. So let's slow down for a second. Think this through. So we could watch the video. Now, if I'm watching the video and I put the video on stream, I will get copyright claimed, or I'll get automatically copyright flagged, and the stream will end. If I watch it off screen, then I can't. Then it's going to look like I'm not. It's going to look like I'm not doing anything. Ultimately, we could go on an intermission for a bit and give me a chance to look at it, but that's kind of boring. Nope. Unfortunately, I think our best option is to skip this part. We're gonna have to. I guess we can't do any printing today. We blew it. Let's get back to. Okay, so then getting back on track. The next thing to do after this is. Let's drain our Let's like. Oh, hang on, Rene. If you know how to do this off the top of your head, maybe we could just dial you. Maybe we could just like get on Zoom or something and put you on the stream. What do you say? You feel like being internet famous? And also, are you on? Oh yeah, you're definitely on Discord. All right. Let's see. I hope this still has battery. Oh no, the landscapers. All right. Can you folks hear the Can you folks hear the landscapers outside? Like, can you hear that buzz? Xneem asks, do X and Y offsets really matter if you print a benchy in the middle of the bed? It does matter, because when we home with a tool, if you have the offset set up wrong, it could like collide something into the side. Okay, so it looks like we can hear that, so I'm going to switch over to the... Alright, the screen's going to go black for a sec as I switch over. There we go. Okay, good. Alrighty, so let's go back here and, I just realized I am going to need to, bear with me one sec. I have to route... I know this is not the most pulse pounding. I know this doesn't sound the best, but nature of the mic. Okay, so bear with me for one sec. I need to route the audio from Discord into... Let's see. I have to route the audio from Discord into OBS so that you can hear the other side of the conversation. So let's see. We want this to be the headset. All right. I don't have... OBS is not fully... I haven't fully configured every contingency here. I don't have like a proper mixing console, so I have to do this all by hand. So let's get back to here. All right, and now let's fire up Discord. Let's see. All right, and let's do a video call. Let's see, and we'll bring this. The screen's not. We're not going to be perfectly set up here, but you know, we'll work with what we got. All right, and let me make sure that my voice and video are set up correctly. Output needs to be input and output. There we go. All right. All right. Can you hear me? Can you hear me?
I can hear you, yes.
Okay, awesome.
I can see you better.
Congratulations for being the first guest to ever appear in a Voidstar stream. How does it feel? You're famous now. You've made history.
Oh, I already am.
Bear with me one sec. Your audio is a little low, so I'm going to turn you up. All right, there we go. All right, so let's minimize this window so it doesn't get in the way. You already know what I look like. Unfortunately, I can't share my webcam, so
no problem.
Yeah. So let's do some 3D printing. I'm going to move. Let's see. We're going to move. How am I going to set this up? Bear with me one sec. Technical difficulties all the time. It never ends. All right, so let's resize you and throw you over here. Let's put our settings and stuff over here. And I'm also going to need to, bear with me one sec, we're going to get into OBS. We're going to grab the big boy camera. I think that's what we want. All right, and let's throw that over here. So the stage is set. Let's build some. Let's build some stuff. Let's make this work.
Yeah. What do you want to do first?
Well, I think let's see.
It seems like the first thing to do, right, is to set the offset so then we can actually print stuff.
Yes.
So what do you think? Is it reasonable to do that if you're walking me through it, or are we completely doomed?
I would start with the Z offsets first.
All
With
right.
all 4 tools, it's rather fast process.
All right. All right, let's do it.
So first of all, to save you some time, is to set our tools in standby. So you can do it by picking and dropping off all the tools,
Uh-huh. All right.
or if you, yeah,
Let's do that because it looks cool.
okay.
Got to give the people what they want, and let's drop that off, and then let's pick this up. I keep forgetting that I can jump directly from one to another. All right, and the other 2 should already be on standby. Very nice.
Yes,
Let's park that.
And then do set all the standby temperatures and the active temperatures to general printing temperature, like 250 or so.
Active and standby. All right.
Yes.
Oops, not 205. All right, so let's set all of our temperatures to 250. It's super crazy that there are 8 temperatures to it, 9 temperatures to adjust, counting the bed.
There's a button on the top, set all.
Oh, that would have saved a lot of time, wouldn't it? Do we want the bed heated up? Right now it's at 75.
It's not needed. Bed is not needed to. The bed 250 is no, it's not needed. You can do this cold. But 75 is okay. It's just for your hot for your fingers.
I'm hearing fans turning on. Bear with me one sec. I'm going to go around and back and plug in the. I'm going to go around and back and plug in the Titan fan, because yeah, we don't want that to burn up. We don't want that to burninate. So bear with me one sec. All right,
Super
cool.
weird to see this 10 seconds later.
Cool. Also, it doesn't seem like we're leaking, which I'm kind of surprised about. All right, so it looks like we're coming up to temperature. The Titan made it there already.
So go pick one tool.
The which?
It doesn't matter. Which you would like to start. 2-0, for example.
Oh, I turned the heater off. Whoops.
It's all good. Or yeah, it doesn't matter.
All right, there we go. Okay, so we've picked up. All right, so we've picked up tool number 0. Our Titan tool.
And because the mesh bed leveling isn't that active right now, but it is active, but your bed isn't level right now. You need to move the printhead roughly in the center of the print bed.
All right.
And then grab this handout from E3D, this one.
I hope I didn't try this out. All right, let's move this guy into the center. See, that looks pretty close. That looks about the center. Actually, let's that looks pretty close.
Yeah, it's good. And if you have this paper, it's like 0.11 millimeter thick.
You've done this a lot if you know the exact thickness of the instruction manual.
No, it's written on there for exactly this purpose.
Oh, it's intentionally made for that. Oh, that's pretty funny. Where did I put it? It's around here somewhere. Fellas, this is why you got to keep your workshop clean and tidy, so you know where everything is, and more importantly, you know where everything isn't.
You can pick a piece of copy paper and measure it.
There it is. Aha! Get that underneath there.
And then you get it underneath there, but you have to be careful. If you drive the bed too high, you can actively push the x-axis upwards and bend it slightly. So you need to be extra careful.
All right. Why don't I change? All right, then. Why don't I change these to avoid fat fingering this? There we go. Okay. Now there's less chance. All right. So now I raise it until we can barely pull it out.
There's this thing with the paper. If you shove it like this,
Uh-huh.
and it bends upwards like so.
Uh-huh.
When you try to shove it, it's too narrow.
All right.
It needs to be shoved under there like this.
Okay. So let's do this. So right now it's very loose. We're moving this by 0.5 millimeter at a time. I'm starting to feel a little bit of tension. Oh, too much.
Way too much. Way smaller steps, please. Take a look. If you're close, use 0.5 millimeter is way too much.
Yeah, we're switching over to 0.05. Switching over to 50 micron. All right. I'm feeling a little. All right, so it's buckling. So let me do this from this side so folks can see. All right, so that's too much.
If it buckles, it's exactly right, or just a bit too much, but it's okay. And then you note the position of the.
All right.
Or switch to your config.g and pick the complete G10 command and copy it.
So run
and go back.
Run G10.
No, not running it. Copy it from the config.g in the system category.
This guy here?
I need to wait for the visual. A bit, sorry.
Oh, right. There's a bit of a lag. There's a bit of a lag going on.
Yeah. And if you copy the whole line, the G10 from the P0, yes.
Uh-huh.
This one, copy it, leave the config.g and go back to the dashboard and then copy it in the input field right in the center above.
Are you sure? I don't want this to crash.
No, I've done this thousands times.
All right.
It's okay.
So I've taken the G. All right, I've taken the first G10 line, the one that corresponds to tool 0, the one that I've got picked up, copying the whole line and running it.
Yeah, it's no problem. It's this line is sets the offsets of the tool. So as the config already loaded it, you just send it once more. It's no problem. So you know the printhead is at 0.11 millimeter right now, but Z in the web UI shows 1.08 right now. So you're gonna adjust the Z parameter right in the input field above to reach that the Z is displayed as 0.11. Was that clear?
So all right, so we'll subtract. Oh, that's not gonna work. That's not gonna work over here. Hang on a second. I'm just gonna pull up a calculator. So we want to subtract 1.8 from 13.5.
You can try an error. Do just 13 or something. It doesn't matter. Just send it over and over. It's no problem.
All right, here we go. I'm sending it, just as is. Nothing happened.
Yeah, and then change the Z value to like 13 or minus 13, not 13.5, and then watch what happens with the Z position in the status field.
Aha. Minus 13. All right. Okay. Oh, all right. So this didn't. All right. So this didn't actually move anything. It just changed where it thinks it is.
Yeah, exactly.
Okay.
So you're changing in the wrong direction. So try Z negative 14.
Oh, gotcha. All right. And we want to bring this to 1.1?
0.11.
0.11. All right. So we want my math. How do I math? How do I math?
Negative 14.4 or 45. Yeah, a bit too much. 14.48.
Oh, there we go. All right.
4.8. 14.48.
Says Z is 0.1.
Yeah, okay, then 44. 47. Yeah, perfect. So copy the whole line again. this whole line
And bring it back into the script.
with the 14.47. You had there was a delay. I was distracted.
There we go.
And copy it back into the script. Yeah, and then repeat for the other 3 tools.
Ah,
So
alrighty. Okay, I thought
copy
that
the
command
next.
actually moved things around. I didn't think it was just sort of like tracking its own location. Alright. Bear with me 1 sec. I'm just going to open up the stream so I can see what you're seeing. Bork says, if the guy says crash it, then crash it. There's your vote of confidence. Yeah, pardon. For everyone watching, what's going on here is that Discord, like the Discord video chat is taking place in real time, but there's always a delay on the stream to allow YouTube to process it. So, yeah, unfortunately there's no good way, like the only way for me to get around this is by sharing my screen twice, and I'm a little worried that I'll be pushing our bandwidth a little further than I'm comfortable with. So here's a question, like when I return this, is it going to be misaligned now?
No.
All right,
There's nothing.
here it goes.
Actually, the G1 commands have a G53 before in the
Whew.
Toolchanger scripts, and these there's the printer coordinates, not the tool coordinates used for docking and undocking.
Gotcha. That makes sense. All right, that makes a lot of sense. So, all right, so we've grabbed tool number 1. So let's drag this. Let's drag this guy over to the center of the bed, more or less. Way too far. It's really hard to do this when looking through a camera. Let's see. All right. All right. Oh, that's really far away. Sorry if the sound is going to drop occasionally because the range on the headset isn't that. Range on the headset's not that high. So, alrighty. Then we do it again. Let's do it again.
Yes. And I need to tell you that you're really brave doing this live on screen unprepared.
I'd say partially prepared. I'd say
I'm prepared in terms of the tool changer.
it's part of the fun. It's part of the fun, and don't get me wrong. I've been putting in a lot of work throughout the week, but thank you. I appreciate your vote of confidence. There's what is it? Fools rush in where brave men dare to tread. Let's see. Come on. Easy. Oh, that's it. All right, it's starting to catch. So we want to back it out a little.
And if you mess up at this point and you ram the bed into the nozzle, you actually push up the whole x-axis, and then you get it bent a bit. So you have to knock it down a bit later.
Oh no! Well, I got a hammer. That's fine.
No, not the just a little bump.
I got a hammer. It's all right. Okay. So all right. So now we repeat the same thing. Right. So we're at minus 185. So we'll copy in the default Hemera tool. Let's see. Copy in. Yeah. Send it. All right. And now. Math. Too many minuses here.
Just try and error. I do the same. I hate math too. So just
5.24. I did it in the wrong direction because I'm dumb. 2.6. There we go. Minus 0.11. Alrighty.
in the tutorials, I actually show the formula of how you can calculate this. It's subtracting from negative numbers.
It's easier to.
Yeah. But you're negative now. Negative 0.11.
Oh, I messed it up. Good eye. And I did it backwards again. My math skills are terrible. I've made this very clear in my streams.
Moving in the right direction, yeah.
0.04. There we go. Nobody told me there would be so much math and engineering. I would have gone to art school. Alright, I'm going to save this but not apply it. Because I expect the power to cut out at any second.
Exactly.
Because
Exactly.
because I'm used to running stuff
Not
here at
restarting.
Voidstar Lab. Alright, so let's dock that one and move on to the following one, right?
Yep.
Easy does it. Easy. I got to adjust the dock on that. There we go. All right. And let's back this out a little more. Oh, we're homing the Y. I hope that doesn't break anything. I accidentally hit home. Let's see. Nope. Doesn't look like we hit anything. Heh.
If you home up accidentally, then it's ugly.
What do you think? Should I return the tool, or do you think I should?
No, just move in the middle.
All right.
Nothing happened.
I've been just like this thing is just.
Do not home.
Huh?
Not do. Sorry, it's again the 10 seconds later you are hovering over homing buttons. Sorry, just in the middle and the paper method. Yeah.
Nope. I'm being extra careful. All right. So this is pretty far. This is pretty far away on the Z. So let's just. This is going to take a few seconds. Let's ooch this in. Actually, why don't I adjust the camera so we can. Maybe I can adjust the camera so we can see more what's going on there. Oh, it's so dark. Oh, that isn't helping. That's making it even worse. Let's see. Give folks an idea of what's happening here. I haven't leveled something with paper in ages. Although it's
Why?
Just because the Prusa has a Reagan says Doc. It's because the Prusa has an inductive probe that handles the leveling, and it's pretty reliable. Cujo26, thanks a lot for the ZAR. Remember the sledgehammer to show it who's boss. We're gonna take a sledgehammer to this. All right, let's carefully ooch this up. Where's our paper? Where's our paper at? Here it is. Let's see. We're nowhere near it.
As I'm thinking about right
there we
now,
go.
your
Huh?
bed was bowed upwards, so the x-axis is probably bowed downwards. So if you ram the bed into the nozzle right now,
it'll correct it.
It will correct it, yeah.
There we go. Hey, our Russian friend, thanks a lot. I really need to put your name into Google Translate. Damn, that's some high stakes calibrating. The tension is real. I know, a slip of a finger and we'll shear the Z homing button right off. All right. Yes, this is high stakes. This is high stakes homing. That's what Voidstar. That's what we needed, right? More drama, more tension.
My personal count is on 5 Z switches right now.
You've ripped. Oh, this is your 5th one. Is that across both, or is that just on one of your tool changers?
It's across. No, I don't rip. Well, no, I ripped one of the new Toolchanger. Yeah, it's 6. Actually, it's 6. 5 on the original right there, and 1 on the new one.
So it's a pretty common part to damage. I've got a few of them coming in
actually,
from DigiKey.
It's always user error. It's the machine did fine.
Yeah, but like humans make mistakes. Technology should be able to accommodate a mistake or two. Oh, that's it. There we go. Let's see. Yeah, it's like this. It's kind of awkward. This one is definitely too tight, but this is a little on the loose side. but I don't think it'll make a huge difference. All right, that's fine. Borked, thanks a lot for the super chat. Add a layer of meta. Have him remote into your PC with TeamViewer. Oh no, that's too many. How many levels of abstraction are you on? 6 or 7, my dude. All right, let's. All right, so this is the one here, right? Yep. This is our. This is tool 3. So we'll.
It should be tool 2 because I already.
Oh, tool 2. That's right. It's our third tool, numbered 2.
Yeah.
Index 2. All right. So let's
start with the one from before, like 5.04 or so.
It's 5.
Or...
I think this should do it. No, I'm dumb. There we go. All right, so they're basically the same. That's good. 0.011, not minus 0.011. Oh, they're not the same. One's minus 5.04, the other's minus 5.4. Oh, that's some precision engineering, Zack. And
all the differences come from the printed parts.
Sure. You don't have to help my. You don't have to soothe my ego. I know. Okay, so now it's the last one, the Volcano tool. This one should be fair. So I tried when I was designing the bracket to mount the Titan. I was designing the bracket to mount the Titan onto the Toolchanger. I tried to make the nozzle the exact same height as Volcano. So
yeah.
So let's
lower the bed first. Lower the bed first, please. If you didn't adjust the Z offset right before, then it can.
I did, but it's still a little too tight. So yeah, you're totally right. Let's drop the bed, and let's move this in. All right, move it over. How are we doing here? We're about in the middle. We're in the middle, give or take. All right, I pressed that that button way too many times. All right. Let's see. Oh no, I homed it. Oh, I hit the home button. Whoops. Everything's fine.
Okay. There's nothing wrong there. You have you should put into a safety measure there, but you need to rehome the printer and completely and dock put the tool back on the dock.
Makes sense.
And then start home.
Whoopsies.
If you want to, we can do a 10-second fix so that this will not happen.
Oh yeah,
again.
definitely. Any idiot proofing measure, we should throw them in, because I am an idiot.
Yeah, go to system and open the homeall.g.
All right, so let's see, homeall.g in the system.
Yeah, and the first line or second line after the first comment, just put a T-1.
Oh,
So.
Oh, that'll dock the
so
tool.
That, yeah, it will dock the tool before any homing. So if there is a tool picked up, it will dock it first. And if there's no tool picked up, nothing will happen.
So doesn't that mean though that if it picks up a tool and then it loses its homing, then it'll crash the tool into the dock?
No, it's only if you press the button home all,
right.
Then only then. Before actually begin with homing, it will dock if there is any tool, it will dock it. Yes.
Gotcha. Maybe I'll modify this because I feel like all right. Let's. I don't want to get carried away here. All right. So we've edited home all. So let's dock the tool and pick it up again, right?
Right now you can just proceed like before. It's.
Oh, I'll just grab the tool off the dock and throw it on by hand.
No. You have home. You have the printer thinks it's still active, so
Yeah.
you do the undocking move and then pick it up again.
So yeah, we'll dock it and then pick it up.
Yeah.
Oh, that didn't sound good. That didn't sound too good. Something
Yeah.
something funny happened.
Probably rehoming completely.
Yeah.
X and Y, and then try again. It should.
Yeah, I
Is
hit home all. Yikes. Yikes on a bike. Yeah, I'm
these sounds are pretty normal.
100% I'm going to break this thing. 100%. I'm amazed I haven't broken it yet. Only thing I've blown... I can't... the only thing I've broken so far is I blew out the fan on the radiator. I can't believe that's the only thing I've blown up. All right. Now
you get used to the sounds.
Let's pick it up. Let's pick it up again.
Lower the bed first.
Alright.
And as soon as the Z offset is applied, everything will be fine in the future.
Alright. So then let's back up and there we go. It's about centered. It's center style. It's like kosher style. You know, it's not really kosher. It's just kosher style. All right, let's do this properly. I should really be doing this sitting down at the printer instead of so far away. But you know, them's the breaks. Let's see. We still have a few more. It's a great back workout. Constantly like going over to double check. All right, give another couple millimeters. Let's see, one more. All right, and we're carefully backing this in. Let's see. So we still have a ways to go.
And I'm already working on a solution to probe the Z offset automatically, so that this will be automatic in the future.
What's can you say anything about it, or is this top secret?
It's basically expensive AF, and it could also be done like on a CNC mill, like the Z offset of the drilling bit.
Oh, is it like one of those like a touch plate?
Kinda,
I guess if you have an all metal system, but then I guess you could do that. Yeah, that would be pretty neat. I feel like the inductive probe from the Prusa would be perfect for this, because like you can have that drop below the tool head. Although maybe that wouldn't work because it would be too long for some tools and too short for others.
Yeah.
Yeah, there really isn't a clean solution, is there?
It's hacky. It's definitely hacky. Yeah.
All right, we're almost there.
And for the
we got it. Sorry, what were you saying?
Do you want to try a multi-tool print right now, or?
Well, I think first let's finish this up. So, all right. So we got our paper in position. All right, and let's get the let's get this thing set right. So we want to drop this. Nope. 14.2 or 19. There we go. All right. Paste that in. And let's save it. Do we want to restart and apply? I don't think it matters, right?
Actually, you don't need to restart because you already put them into the input field. But it doesn't matter. But you did restart the printer while the tool is still attached. So you need to grab it before homing. or it will fall like before.
All right. So I didn't restart it. I hit no.
So, okay, sorry, I get you wrong.
All right.
So undock.
All right.
I got you wrong. Yeah, okay, sorry.
There we go.
And then you need to adjust the X and Y offsets. This is easiest and fastest done with a microscope, looking from below into the nozzle. But you can also do it by hand and measure it. With a
Oh, you
caliper.
mean like put a camera on the plate pointing up?
Yep.
Oh,
This is the easiest.
let me think.
But
Oh, that's pretty interesting. Easiest thing would probably be like a Raspberry Pi, Raspberry Pi camera, right?
yeah, or a cheap USB microscope. Yeah.
Let's see. I have a USB microscope, but it's kind of on the tall side. Here, check this out. Oh, Michael, thanks a lot for the super chat. Maple syrup bucks to help pay for what you're about to blow up. These folks are starting to learn. Folks are starting to learn how I do things. So yeah, what do you think? Is this guy gonna work?
Yeah, this is gonna work.
All right, so
Definitely.
let's flip this.
Good thing.
Let's flip this guy upside down.
Yeah. So now you need to grab some sort of sticky tape or something, and you need to tape it to the print bed. So because every time you grab a tool, the print bed is moving up and down. It will.
It's gonna shake.
Maybe shift a bit.
All right, so let's. All right.
Blue tape or something.
Yeah. Let's see. So what? So I can just do. Let's say G1 Z100 to drop the bed a lot, so I can get this on it.
Yeah, sure. G1 Z200. Yeah.
Oh, I put everything. Everything's fine. Okay. Let's see. G1 Z200. Let's say.
Yep.
Finger on the emergency stop button.
You're safe to travel to around 285.
Gotcha. I don't think I've ever actually brought this thing down all the way. I think this is as far as I've ever gone.
Yeah. You have to account the Z-hop and the lowering of the bed when you drop the tool off, so you can't go all the end.
Gotcha.
All the way to the end.
Makes sense. All right, so let's get this guy. All right. Oh, yeah, this is the problem because like, if I set this up so everyone else can see it, then folks can't see you. Oh,
doesn't matter.
Oh my. Well, let's show. Here, give me one sec. All right. So, let's see. So we've got the microscope. The microscope is somewhere near the center of the bed, right?
Yeah, it doesn't matter where exactly.
All right. So let's make sure everything is locked in. Let's get our USB cable. Let's lead our USB cable out and away, and let's get some gaffer tape. Don't want to leave too much residue, and let's gaff it. That's what I used.
Is the microscope sturdy on its mount?
Yeah. It's vaguely wobbly, but I don't think it's terrible. Oh no, the tape is sticking together. Let's just double check. It's not the sturdiest mount, but it's fairly close. All right, and let's tape this down. Oh, I can't believe it took so long for me to think of just putting you on a video call.
I'm here to help.
Yeah, I know it's really late for you. I really appreciate it. Let me know if you have to go.
It's fine. It's weekend.
Oh, that's true. That's true. It's already the weekend for you. All right. Looks like we're as locked in as we can get.
Yeah, and I don't want to have don't want you have the fun all alone.
I see.
Yeah.
Let's. All right. So now, let's see if I can get this. All right. Let's see if I can get this on screen. Stand by. Things are going to go dark for a sec because I want this to appear in every one of our screens for now. So let's see. We want a video capture. We're going to create a new one. We're going to call it Micah Scope after my brother Micah. Let's see, digital microscope. This microscope sucks, by the way. I doubt that's going to be a problem, but you know, just heads up. This microscope.
The cheapest will do.
It's pretty bad. It wasn't the cheapest. I got ripped off. I'm not too proud to admit it. Let's see. All right, let's park this guy. There's no really good place for this, so we're just gonna. I think people know what we're doing by now.
You can just shrink the screen, and we only need the center of it.
All right. Well, let's wait till we got something in it to show. And back to. Oh right, I unplugged my number pad so that I could plug in the microscope. That explains why that's not working. Haha. Boop-ba-da-ba. There we go. All right. There we are. We're gonna have to focus this thing up. All right. So what am I doing? Am I picking up a tool and getting it right over the microscope?
First, you need to cool down all the nozzles because the heat will damage the microscope
That is
eventually.
a good point. I don't really care that much about the microscope, but seems it does need to last until the. Oh right, we can just use turn everything off.
Yeah, and then just grab the first tool and ride it over the microscope, but not hitting the nozzle with the microscope with the nozzle.
All right.
And
let me just double check. Yeah, this is totally going to crash. We got to move the bed down even further.
And then it will help a lot if the microscope is orientated in a way that it matches the coordinate system of the printer. So up is up, or up is Y plus.
I didn't know that. I didn't know this G is absolute coordinates. We almost had a crash.
Whew, that was close.
There we go. Oh, everything's fine. All right, so I moved this down to 250. I think my mic just cut out, and now we're back. All right, nobody can see anything, so I've got to readjust the camera a little bit so that...
That was a close call.
Yeah, we have a lot of those here. I just heard a sound.
I'm not sure what happened. Why did it go upwards?
Oh, because I wanted to drop it by... So I wanted to drop it by 50. I want to drop by 50 millimeters to give it more breathing room. So I typed G1Z50 because I thought it was in relative coordinates, but it's in absolute coordinates. Azundo, thanks so much for the 69 Canadian pesos. Nice. Thank you so much. That's so generous. I really appreciate it. That's Azundo's been so generous with the stream. Been a huge supporter. I really can't express my thanks here. Thank you so much, my gentle sir. I don't even know. People are just words on a screen. I don't even know if you're real. Like this guy here. Who knows if this guy's real? It just could be an AI or something. It could be a chatbot. All right, enough monkey business. Let's start with tool 0, right? Let's start with our water-cooled tool. Pick it up. And let's try not to kill it. Let's try not to crash and kill everything. Oh, it bottomed out. Does that matter? It bottomed out and squealed.
Oh.
It made a very disconcerting noise.
How long?
Huh?
How long was it seconds or just a
part
moment?
of a second, maybe.
Okay, so your length of the z-axis doesn't match the actual limit of the z-axis in the config.
Maybe. Oh, wait a second. Nope, that's what it was. It was the cardboard boxes and the blocks of foam I put at the bottom to catch any extruders that fall off their docks. It crashed. It crashed
Did the
into
motor
that.
stall?
Huh?
Or did the motor stall, or are we still in the right position?
The motor stalled.
Then you need to rehome. Yeah, no, it's not needed if we do it carefully.
Well, the Z, right?
We
The
just
Z
assume that
dimension, or the Z, the Z doesn't matter, right? Like the 'cause-
not that much. Yeah.
So what do you think? Should we
Just
go?
move
Should we
it-
go
just
forwards,
move
or
it
should I
like-
take the microscope off?
No, it's fine. Go pick the first tool you want to adjust
Yep.
and move the nozzle over the microscope.
All right. All right.
We just have to remember right now that the Z isn't
The Z is wrong.
the right coordinate.
All right, chat, we're counting on you. Lauge Blake Nielsen, sorry for pronouncing your first name wrong. Thanks so much for the 69.69 kroner. I know it's not much, but it's honest money. Nice. The sex number. Thanks so much for the 69.69. That is the advantage of having currencies that have higher units than the US dollar, is more opportunities for 69. All right, let's see. How do we want to do this? I'm wondering if it makes sense to fire up the cyber deck. I'm going to switch this back to 10 to move 10 millimeters at a time. I wonder if it makes sense to grab the cyber deck so I can sit down closer to this. Might make it easier to control.
But you don't have to go to the printer right now.
Just trying to line them up. This is tricky.
So first line up, and then you focus with the offset with the z-axis.
Gotcha. I don't remember where I had this thing focused, but it's probably something really stupid. Let's. Ow. I didn't whack my head into the camera. You whacked your head into the camera.
And this is the moment where I told you that it would actually help if the microscope is orientated in a meaningful direction. Like the thumb wheel is the top of the cam, and usually,
Yeah.
I think.
All right. So let's. Let me. Why don't I focus it? Let's focus it up a little. Let's see.
Do you happen to know where the orientation of the microscope is?
Hang on one sec.
Oh, and further away is better for focus for the nozzle thing.
Gotcha. All right. The it should be good. I'm bringing the paper from the top, and it's coming in from the top. Bring it in from the right. Oh, it's coming in from the left.
Yeah. Okay. Left and right isn't that critical.
We can always. I can flip it in. I can flip it on OBS. So let's see. Do you want to flip left and right?
Yeah. It would be helpful and less distracting. Yeah.
All right. Screen's gonna go black for a sec. Let me open up the microscope, and we're going to transform. We're going to flip vertical. Nope. That's not what we wanted at all. Let's see. Come on. Transform. We're going to flip horizontal, and we have to flip it back vertical. Flip vertical. All right. So now coming in from the left. Coming in from the right. Coming in from the bottom. There we go. All right. Cool. Okay, so now let's get back to the screen with all the stuff on it, and let's line her up.
So regarding the XY offset, you need to know that the actual origin of the coordinate is the Z home stop, the center of the little nub of the Z end stop. So this is 0, 0, X and Y. So
Oh,
if you
okay. All right, I gotcha.
put any offset in, yeah,
So
don't move the microscope.
no,
And just
the
move
microscope was
the
turned, so I just evened it
oh
out.
yeah. And the
All
thing is,
right.
what you do is you make a little overlay or via USB, OBS,
Uh-huh.
or something like that. So you actually ever find the exact spot
Oh, and
about above
put a little
the microscope
crosshair.
again. Yeah, process
All
best. Yeah,
right, bear with me one sec. Let's add in. What do I want to do here? Is probably just want let's just put in a plus, right? Okay, so we just want some
yeah.
text. Where's the text? Plus, or let's go crosshair. Uh, is probably a little. I just need to find a thin one. Hang on one sec. Futura light. No, we don't. Hang on a sec. Futura. We don't want the. There we go. And we probably want this a color we can actually see, huh?
And maybe see through or something. So because this is rather thick.
Yeah. Where's our alpha channel here? 50%. There we go. Oh, that's not enough. We need more than 50%. 750%. No, 75%. There we go. All right.
Okay, uh, and I made a little whoopsie because we are setting up the microscope right now to the end stop. We need to dock the active tool first because the
Oh,
offset is different.
son of a gun. All right. Let's not home anything and destroy anything. So let's don't crash. Come on, easy. Ah. All right, because it had the coordinates applied to it.
Yeah,
I
and then
see.
just move the end stop back to the crosshair
Ooh.
and take a note of the X and Y.
So this is about I don't know, probably three. It's about an inch away. Like, do we want it to be close to the microscope, or it doesn't matter?
No, you'd adjust the height with the z-axis. So you just focus on the end stop. The z offset will be applied for each tool also.
Gotcha. It doesn't matter how close or far we are.
As long as you can see clearly, yes.
All right, where is that friggin' tool? Or where's that friggin' button? Oh, I'm on the wrong side. Oh, we missed it. There it is. There we go. All right. And where's our X? No.
There is, yeah.
All right, hang on a sec. I just need to adjust this down to 1. Oh, you can't see it. I forgot to put the friggin' thing back on the thing. Aw, jeez. Aw, jeez, Rick. All right, let's line this up. Almost.
And if you're satisfied with the centered position of the end stop, you just take a note of the X and Y and Z coordinates.
All right,
It has to be in focus somewhat.
that seems pretty solid. That seems pretty good. All right, so let's
Okay.
so we got to take down our X and Y. So let's put that over here.
And X, Y, and Z, the coordinates, and you put these coordinates in a macro. So we need these rather often.
All right, so this is calibration. So this is the calibration reference point. And
Yeah,
let's see.
exactly.
X is 150.8. Do we need the Z?
All the coordinates, all three.
7.3, because our Z is messed up from crashing into the cardboard boxes.
Yes, but it doesn't matter. We take it for granted right now.
All right. Crashed, not real. Okay, so we've got our coordinates written down.
Okay, now switch to the macros tab and create a new macro.
The macros.
This will speed up the process.
All right.
Yeah.
Macros, and let's make a new one. And what are we going to call this? Calibration or something? Offset.
I called it move the microscope. Oh,
Move microscope. All right.
that's my clever naming. And then you put in the coordinates with the G1 command and probably a reasonable speed like feet of 10,000 or so.
All right. All right. So G1 X 150.8, Y 97.3, Z 192.52, and that's at 10,000.
At 10,000, yeah, that's fine. And then to speed up things even more, next line, or the line before, just create line before this command and offset the X and Y coordinates by random amount, like 1 millimeter or so.
All right. What's the command for that?
It doesn't matter that much. It's just G1 and then X 150.5 and Y 96 and the Z coordinate again. And this one with a rather slow feed, like 1,000.
All right, so I'll just add I'll just add like part of a millimeter to each one.
Yeah, it has to move. Yeah.
Oh, gotcha.
It doesn't care. Yeah.
And that's at like what, 2,500?
Do G1 X 150.5. Yeah, it's okay. I see it 10 seconds later. Sorry.
I know. I need to adjust the latency.
The Z offset needs to stay the same. So we are not moving in Z.
All right, done.
So what this macro does, it moves to the microscope, and every time you call it, it will move the printhead and move back to the microscope.
Gotcha.
So offsets are only applied to the actual tool position after a movement.
Gotcha.
So we did the offset from the Z before, but we didn't move the Z axis again. But this time we need to adjust it over the microscope, and we need to verify the movement. So we needed this little macro.
All right. Okay.
So now you can pick up the tool you like and execute this macro.
All right. Let's drop the bed a bit. And drop a little more. Yeah, let's drop a little more, and let's pick up our Titan tool. Oh, it's still working. I'm amazed. All right, so now we run our new macro.
Yeah. Do you have it on short dial on the right side?
Let's see. It doesn't look like it. So
okay, so you get to rename it and put a 0 up front, 0 lower dash, and then it's automatically sorted to the top of the line. On the
how do I rename this? Oh, here we go. Rename.
Right.
So here. 0 _ move microscope.
Exactly. And then it should be on the first position. So you can sort the short dials.
All right. It hasn't updated yet. Yeah, it's still the same. Do I have to refresh?
Try.
Do I have to
normally
reload the interface?
It doesn't. Try it. You can't break anything.
Oh, there it is. Oh, hey, there you go. Nice tip. All right, so now let's run it. Ready?
Yeah.
All right, I'm gonna move the mouse immediately to the emergency stop button. All right.
The emergency start button doesn't take effect after all moves are done.
Well, crap. Maybe I should plug this thing into a power strip and just kick it. Later. All right. So now I'm trying to center the nozzle.
Yeah, normally, then it's the nozzle should be about above the microscope, but the Titan offset is probably far off.
Yeah. I just guessed.
So yes, now you do the thing with the Z offset again, and you copy the G10 offset line off to 0 and adjust it. And after each adjustment, you hit the move to microscope button.
All right. Okay. Oh, this is looking good. Almost there. All right. Okay. So let's see. So what am I doing here? I'm trying to.
What you do right now isn't necessary. Sorry, I see it only 10 seconds later. So you need to copy the G10 command from the config.g.
Uh-huh. Let me get back
Like
in there.
before.
I'm still in the macros menu. So let's see. All right. Are we almost there? Yeah, next time I'll turn on super low latency mode. Okay, so here we go. We've got our G10 command. And
copy it and put it into the input field.
all right. And
then
so
you adjust the coordinates.
Oh, to try to get this to be the same as our other coordinates, like the coordinates I wrote down of the end stop was 150.97.3. So now I'm trying to adjust this to get.
No. Adjust the x and the y by a few millimeters, and then then send this command, and then hit the move to microscope macro button, and then watch in which direction the tool head is moving. And the goal is to get the nozzle with this above the microscope.
Gotcha. All right. So first, let's try.
Without jogging, only without any jogging buttons, only with adjusting of the offset.
Gotcha. All right. So let's try increasing x by 5.
Yeah, that's the way.
And now we run the macro.
Exactly.
I think that made it lower. So now let's try increasing that further by, let's see. So let's send that and move. All right, we're getting there. This is going to take a few seconds.
It's only because you didn't have the right ballpark from the beginning, so it's a completely new tool.
Yeah, it's tricky. I had to design the whole thing. Don't get me wrong, I love designing stuff, but it was unexpected.
I think you do great.
It ended up being actually a really elegant design. It ended up being well, basically it's basically the frame is one piece.
Cool.
Yeah, it ended up being actually a pretty.
Is it on Thanks?
Design. The which?
Is it on Thanks? This design?
Haven't. I didn't want to upload it until I had tested it in real life. Okay, so this looks good. So this is now our. So this is it. Right, like
let me give me 5 seconds.
Oh, sure.
But it starts looking good. Yeah. Okay. So copy this back into config.g and repeat with the next tool.
All right. Bear with me one sec. I'm just gonna in smallen this so you can see what's going on more easily. All right. So this goes back into config.g. Oh, it's happening. It's happening. We do not want to restart. I do want to save though. All right, so now we'll dock this and pick the next one up.
Yeah.
So this one should be close because I'm using the same coordinates right here. But after this is all done, we will put this all on Things, the sponsor of today's episode. Thanks a lot to Things for supporting Voidstar Lab and allowing us to do crazy streams like this and make all kinds of cool projects. If you're interested, whether you model stuff or you want to make stuff, if there's stuff involved, there's a 3D printer and there's an STL file or anything, head to things.com using the link in the description. And you won't be sorry. I really like Things. I've been using it to host everything I've been building, and it's not just because they paid me. Certain other sites have had reliability problems, but even if you use those other sites, you can still search them on things.com. So thanks a lot to Things for sponsoring the episode. Now I interrupt the shilling to do some actual project making. All right, so we've copied this. So let's dock the first tool and pick up the second. All right.
And that is the standard one.
Yeah, this is a regular Hemera.
So the actual ballpark should match.
All right. So let's see. It's close. It's close. What do you make of that though? Should I adjust the homing? Should I adjust the offset, or do I have to tighten some screws or something?
No. Just adjust the offset. I expect you did everything good on the tools. So.
All right. We have an interesting question in chat. Pardon me. Beefingit asks, "What are Things models licenses like?" You can upload whatever license you want. I always use a Creative Commons. I always use a Creative Commons attribution, non-commercial, personally. But you can upload whatever license you would like. Wrong direction. Woo. Good question though. Licensing your open source projects is very important. Public domain is actually not what you want if your intention is to share your work with the world. Nothing stops someone from enforcing a copyright on a public domain work, or making a minor change and getting the copyright on that. So you should always license your work, even if you're a diehard open source head. That's your American.
Am I allowed to?
Oh yeah, please. You're not just here.
Am I allowed to?
Not just here as tech support. Yeah.
Okay. I just want to tell that I did many hour-long YouTube tutorials about exactly this stuff. So.
Oh, yeah,
if you have the time, you can just watch my tutorials on exactly this.
Got to check out Rene's channel. Yeah, you've done a whole bunch of them. I didn't know which ones I had to look at, or I would have checked them in advance. But it's good to have you on the stream. But yeah, you definitely got. Is your channel just your name, or are you working under a pen name? So,
it's Vinny Luwak, yeah.
So that's So we're gonna want to go to YouTube. Yeah, there we go. YouTube.com/Rene.
It's like.
Oh, that's not enough subscribers.
It's like Thomas and Hemeras.
That's not enough subscribers. You need some more subscribers, folks. You know what to do. Yeah, you know what to do. Get on there and hit that red button that's being blocked by a microscope right now. Yeah. Can I put links in my own? Can I put links in my own chat, or is it going to block me? Oh, there we go. Awesome. All right. Yes, I totally. Yes. Shameless plugging is part of the game. All right. G10P1. All right. So that's it. Shall we move on to tool 2?
Yeah.
All right. And it's the same. Nothing's changing. Same procedure.
Yeah, same procedure. Because we include the Z, this will also affect the volcano.
All right. Volcano should be fairly close to the. Volcano should be hopefully close to the whatchamacallit, to the Titan. Let's see. So this one, yeah, it seems almost the same. I'm gonna copy. I'm just gonna copy the X and Y here. So this is 5.4. All right, so let's change between tool 1 and tool 2 and change 5.04 to 504, send, move. All right, so it looks like this is a little bit off, especially on the x-axis. Let's change this. Oh, almost.
And these little offsets come from the printed parts.
Yeah, and probably my drilling as well. Yeah. So, by the way, you mentioned before that you're worried that you're worried that the nylon would deflect in heat. So, I annealed everything and then I tested one, and it should be stable. Should be stable all across our all across our temperature range. Okay. So looks like we're set here. In we go. And finally the volcano. All right.
Yes.
Let's swap it over. This is the point where we're going to get overconfident and make stupid mistakes. So we need to avoid irrational exuberance. All right. Move that mica.
As a non-native speaker, your words are.
Oh, that's close. That's close. Yeah. So look. All right. So we should be able to do this pretty easily. What's wrong here? Did something bind? Why isn't it moving? Something. It doesn't look like it's moving very much. Oh geez. Oh, we were doing P2, not P3. I'm gonna rerun this. We're editing the wrong tool.
It's not on problem.
Yeah, I just want to make sure.
It's not bad. Just copy the other line.
Yep. All right. So let's. Here we go. Oh, wrong direction. Zack never learns his lesson. 4.3. Oh, huh. All right. That's looking all right. It's looking pretty close. 4.6. All right, and almost too far. A little bit of a Goldilocks Three Bears thing going on here. I moved in the wrong direction again. Everyone's ripping their hair out. Imagine if I were a game streamer. People would be like backseat gaming like crazy. All right, and that's it.
Yeah. That's it.
That's it.
And the whole process with the microscope, there's a software called TAMV, TAMV, and this stands for some machine vision tool alignment with machine vision, and it's done automatically. You set up the microscope, you hit the script, and it automatically drives each tool to the center of the microscope, detects with machine vision.
Oh, that's really cool. Let's see. Oh yeah, this is it. I don't want to get copyright struck, so I won't take a look at it. But yeah, check this out. Tool alignment with machine vision. I gotta check that out.
Yeah, and with this tool, you can get it down to like 10 seconds per tool.
So it automatically. That'd be sick. Oh, that'd be really cool. Hey, Brooke is trying to get my attention. Lepidoptera lady asked if I can do CMYK prints when this is done, and I want to know. I guess like if it was half toned, right?
It has been done.
Oh, it has?
It has been done, yes.
Is there a? You think
I have
there's
to look it up, but yes.
You think there's some pictures online?
Yeah.
CMYK. Let's see. See something to print.
I remember it seeing on Twitter.
Let's see if any pictures show up. Huh. Doesn't look like anything's showing up right now, but I guess so. That'd be pretty cool. Yeah, it's you must have to do it with like with halftone, like drawing dots of one, grabbing the other dots, so on and so forth. That's pretty sick. That'd be pretty neat.
And you can also do do it with the spacing between the tracks. So if you do white underneath and you do blue in different tracks spread further apart, you can get lighter blue, darker blue.
Huh.
I think Ruby. I don't remember the exact name. Ruby did it. A well-known.
I bet Billy
maker.
Rubin knows
Maker,
everything
yeah.
about this. I bet she can tell us in seconds.
I think that's the one.
I
Billy Rubin.
don't think she has. I don't think she
I
has
think
a
that's the one.
Toolchanger, but she definitely knows. If this has been done, she knows it. All right, so
if I'm not mistaken, I think that's her.
oh, I gotta. Then they'll definitely ask her. So what? All right, what now? What?
Remove the microscope.
Oh,
Drop the tool. Home the machine.
Let's get these out of here. Very nice. All right, so let's. Yeah, we do have to rehome it, don't we? We kind of blew that. Let's see. Let's switch back to here. Let's get that microscope out of here. You served us well. Piece of garbage microscope. It's brand name too. I'm really salty about this. High-end scope cams are so expensive. Although if I were to have bought a proper scope cam, we wouldn't have been able to get it on here. This'll This will return. All right, so let's home all. Oh, first let's drop the let's drop the tool so we don't ruin everything. And
if you press home all, you can test the T-1 we did before.
Oh, that's true. Well, we'll have to do that next time. We'll have to do that next time. Okay, so this is homing. It adjusts the C-axis first. Yeah. Is there a reason why it homes the C-axis first instead of the X, Y, and Z? Probably makes sense to do that last because then you get immediate visual feedback.
You could.
So it looks like our Toolchanger and our coupler is behaving well. So we can put we'll put the cover back on. Maybe we'll print your cover. Maybe we'll print the fancy one that also covers up all the wires and stuff.
I made a blank cover so you can modify it to your own liking. It's available on my website to download.
We could put a certain logo on there. Maybe we'll do that later. All right. So Reagan says, is this being automatically blocked because it has the word black in it? That's awfully aggressive chat protection. Reagan says cyan, magenta, yellow, and K is black. I guess, but for real connoisseurs, we all know that B stands for black and U stands for blue. Okay, so now what? Or are we ready to print?
Yeah, what do you want? Do you want to print with one tool, with 4 tools, or do you want a multi-tool print?
I think we should probably start by running a separate print on each one, right?
Do you have the slicer set up?
No. I do have a number of slicers.
Yeah.
Let me make sure I didn't miss anything.
Simplify 3D is.
Simplify? I don't think I have Simplify.
Okay, so they all work.
Or is Simplify
at the
best?
moment, Simplify is the only one supporting tool changing fully.
Gotcha.
And Prusa Slicer and Super Slicer do Prusa Slicer is made for one nozzle and different materials.
Gotcha.
And as soon as you have different nozzle sizes, you get workarounds, but it's tricky. It starts to get tricky, and not all features will work. And with Super Slicer, it's like Cruiser Slicer
$150.
for tool changing.
Bear with me one sec.
But you can use Super Slicer, and I would recommend Super Slicer. But Super Slicer is still not. The guy that is working on it is working hard on it, and
But it's not
the
quite there
tickets
yet.
I do via GitHub. Yeah, but it 89% work.
Now, what
So
do you think? Would
for what you want to do, it works.
Is there a specific version of Simplify 3D that matters? For instance, if one were to have some way of downloading an older version, for instance, hypothetically, possibly.
No.
There aren't a lot of. If this were a BitTorrent, then this one certainly doesn't have a lot of seeds. Assuming it were a BitTorrent, let's. If I wonder, I don't know if the Pirate Bay still exists. But if it did,
But you can Super Slicer is probably the way to go, because Simplify 3D is missing out so many features nowadays.
gotcha. All right, well let's then if you recommend Super Slicer, then we'll do that. Let's see. Oh, it better not make me. If there better be a precompiled release, or I'm going to flip this desk.
Yeah.
Oh
it is.
no. Let's see. Where's our release? Let's see. Do we? Oh, I should probably be doing this in this window. So folks are asking how I'm snapping the windows. This is Power Toys, but I believe it's been added as a first-class feature in Windows 11. I haven't checked that out yet. So let's see. Windows 64. Why are there two versions? Oh, B? Wait, B? What's the B version? All right. I guess we want the
I
B
don't know
version.
exactly.
Why do people version things in so stupid ways? Right. So let's download this and set it up. I've never even heard of this one before.
The thing is, the PC I'm on right now is I don't have Super Slice on it. So I can probably give you an older config file for it. But I can't take a look at it.
Gotcha. Hey, it's up to you on how to proceed. If it's too hard to do from arm's length, we can always just use a different slicer.
Yeah, so I'm familiar with Simplify 3D, so I have everything set up with this one, but I just did send you a config file for Super Slicer.
All right.
I'm sure it is okay, but I'm not that sure that I would trust it blindly.
All right. So, let's see. So we got that. Let's take a. Bear with me one sec. It would take a while to get a Simplify 3D, and I'm not sure I want to drop $100 midstream. Oh hey, I think our enclosure showed up. Brooke, if UPS dropped anything off at our front door, feel free to bring it in. Yes. Oh no, Witch King 64 said it's a first-class feature and a second-class OS. Aw, womp womp. That's mean. Yeah. What do you think it would be? Oh, let me pull you back up here. You think it would be easier for us to do? Think it would be easier for us to use Prusa Slicer or Cura?
I'm familiar with Prusa Slicer too, so
all right.
Yeah.
Let's work with Prusa Slicer then. Unless you think we should, unless I should, or we could load up the. Oh, did I open this? I did. I appeared to have opened it. This looks a lot like Prusa Slicer. It's not letting me resize the window.
If you tell me how to export my setup.
Let's just use Super Slicer. Bear with me one sec.
Slicer is the same as Prusa Slicer.
All right.
Basically.
There's no. All right. So unfortunately, everything's being blocked right now by this window, and I can't resize it until we're done with the wizard. So, yeah. Anyways, okay. So welcome to the Wizard. Yeah. Okay. What are we doing? Custom. We're gonna do a custom printer.
Yeah.
Define a custom printer profile. So we'll call this Toolchanger, or let's see,
As you like, yeah.
the ultimate printer with 4 exclamation points. All right, choose a type of firmware. We're using RepRap, right? Yeah, we're using RepRap.
Yep.
Size and shape, or are we gonna load this? Where do we bring the INI file in?
You can import it later.
Oh, all right. So what's
I think. I'm not sure about it, but I think.
So what's the shape of our? Oh, geez. RepRap firmware. All right.
It's 200 by 300.
200 by 300. Oh, that is a big print. Or is a big plate. Or is it 300 by 200?
Or other way around.
Yeah, that makes sense. Yeah. Do we care about models and such things?
No.
Oh, hey, it's Brooke.
An hour ago, it's been sitting here.
Brooke says it's been sitting here for an hour.
I sent you a Discord.
Oh, I missed it. I love you. Not you, Renee. You're all right, but you know, she's special. Thank you. All right.
I'm fine with it.
Okay, nozzle diameter. We'll do 0.4, right? All right.
I don't know what you have equipped.
Okay, I mean, I've got a
But you can
0.5.
start with.
I got 0.5, 0.4, 0.4, and 0.6. So I think.
So adjust as you like.
Yeah, we'll use extruder number. We'll use extruder number 1. One of the 0.4. Just the basic Hemera. Reduce the points of failure. Alrighty. So extrusion temperature. Let's go 60 on the bed and 210 on the filament. That's about right. For PLA, we'll use PLA. All right. Check for updates. Update some presets. Yeah, why not? Export. No, we're not going to export full path names because some of my path names are going to be a little on the rude side. Right, 3MF files for Super Slicer. I don't know what those are. But no, STL files. All right, let's not mess with associations. Shh, don't tell anyone. Advanced mode or expert mode? Expert mode. All right, here we go. Okay, so now let's.
Okay.
Oh, it works with the space mouse. Woo!
It's like Prusa Slicer.
It is a lot like Prusa Slicer.
Every feature from Prusa Slicer is copied into it. Yeah.
Huh. I guess they could, because like Prusa Slicer's got to be an open source project.
Yeah.
All right. Cool. Oh, it's definitely, this is open source Prusa Slicer. All right, so let's load this in. How do we do this? Configure.
Not that sure about it.
How do I don't even. This is how often I load in. Or I remember at one point. I remember at one point you had to like throw it into a certain folder and then like something like that maybe. Or import config bundle.
Yeah.
Oh, there it is. INI. All right. Okay, we are imported. All right, we got some. We got a whole bunch of tool.
And if the profile is good,
we got a whole bunch of Toolchanger.
Yeah. So if the profile is good, it takes 10 seconds for me to see it. Then you should see 4 different. Maybe you should resize the frame. Yeah. Oh, you already did. Okay. So these are the tools. Yeah, exactly. And yeah, now you load a multi-tool print in or some STLs or something like that.
Yeah. Let's find. Let me think. What's a fast thing to print? I'm sure printing the Voidstar Lab logo. I have a few of those kicking around. Let's see. Where did I put that?
Or you go on thanks and Google.
That is true. I could use our I could use our sponsor's product. Head on over. Let's see. If we want to find one that's fairly quick, so that we can ideally we can finish it. Oh, this looks neat. Let's see. Got some gears. Probably a bit too aggressive for, a bit too ambitious for a first print. Let's see what else. Hey.
Did you set the the steps per millimeter for the extruder?
I don't think so. No, definitely not.
Then
We probably want to do that first. Look at all these
then this
D&D things. Wow, this is really impressive. This is hang on one sec. This is really impressive. Look at all these D&D guys. That's pretty cool. But that's not what I want. I want. Let's go to my things, because I know they're the good ones. I know they're the best. All right, here we go. Got our Voidstar Lab logo. That's the front one. Oh, geez. I hate when websites override the override your mouse and stuff. All right. Cool. All right, so let's download the logo. Oh, how do I? All right, yeah, let's download that. All right, and we have all our STL files here, and let's throw that in. Voidstar logo. Oh, I have to extract. I probably have to unzip them, huh? That probably helps. It helps to unzip the files you're working with. Maybe this is a little too big, but all right, whatever. It's not going to be. It's not going
and
to be
if
very
you
heavy.
drop them in, the slicer will recognize it automatically as a multi-print,
Uh-huh.
and you have to decide if you want to do it one way or the other.
Huh. So, it's
If
giving me a
if
choice of
you
extruders here. Ah. So I assume default is 0? 'Cause I'm seeing. Yeah,
sorry,
it's giving me a drop-down list of extruders. It's got default 1, 2, and 3. But
yeah,
but default and 1 are the same color. So are we
um,
missing an extruder?
default is always one. And now I recognize that this profile is the generic profile from the E3D GitHub months ago. Sorry, there is only 3 because
Oh,
the fourth is reserved for the assembly tool.
for
But
the
you
what?
can add the fourth one very easily.
Well,
The assemble tool,
oh,
the
gotcha.
CNC thing.
All right. So the one here is going to be tool 0, and this is tool 1. All right. So
Exactly.
who's on tool 1? So first before we go any deeper, right? We should probably load some filament.
And adjust the steps.
Yes. All right.
And
So,
for the E3D things, you can use the generic values. You don't have to recalibrate them by hand. It's not needed anymore.
all right. So then let's go back to here and let's set our steps. Where is that? Where does that happen? Is that
Maybe someone in the chat is fast and can Google the steps per millimeter for the Titan and the Hemera.
Hemera, yeah.
Hemera.
Hemer. I don't have
How is it
how do you
pronounced?
pronounce? I have no idea. Nobody knows. I've asked like 4 people have given me like 5 suggestions. Okay, so let's see. Micro stepping, speeds,
I ask
acceleration.
Greg next time.
I don't even. Is it named after something? I'm intensely confused. Normally we would end the stream at
I'm
this
gonna ask.
around now, but I want to at least get some filament squirting out of that thing before we cheese it. I'm not seeing anything here about steps.
it's higher. It's where the axes are. It's relatively at the top. I can't help you because I see it 10 seconds later,
Right.
and you scroll fast.
Yeah, my
It's
bad.
right at the top.
Maximum speeds. All right. So, hang on one sec. So it probably starts around here, right? Let's see. Yeah, there we go. It should be scrolling into view right now. There we are.
Okay, in the chat it says Titan 834.
Oh, that must be here. That must be these guys on this
Yeah,
here line.
M92.
I'm gonna. Oh, that's very long. This should be set to low latency. It should only be 5 seconds or so. Maybe. Yeah. All right. So we'll set this to 837. Yeah, 830. So 837. 407, 407, 407.
If the chat says so, I can check mine. Wait a minute, I cross-check mine. I have the Hemeras on 409, and the Titan I can't say anything about the Titan.
I'm seeing folks in chat say it's 834. Let's see. Matt underscore says Titans 834, and Ryan 3003 says it's 837. Lepidoptera lady says hernia is 1337 for Teen Titans Go 842. I'm not gonna believe her. I think she's BSing. But yeah. So is this where we set it in this line here? Have I done this right? This bit that I highlighted.
Yeah.
I really need to start highlighting before I even talk about it. Like it's all that. This is all work in progress.
Titan Aqua is 837. 837 is the Titan Aqua.
All right, so 837.
Yeah.
Okay. And so that's it?
And now you have configured the steps per millimeter, yes. And yeah.
I probably want to run this though, right?
You're good to go.
Or should we reboot?
If you don't want to restart the printer, you can copy the M92 line and paste it in the input field.
I think we should restart the. Like we've made a whole bunch of tweaks. We've messed around with a lot of stuff.
Yeah,
I think we should apply. And also, this will pick up any problems in our configuration file.
Yeah.
So let's see. It restarted. So let's see. We've reconnected. Should probably add in auto home and auto leveling to our G code, right? Or do you think that doesn't matter?
The printer is set up to automatically do this. We are the tool changing scripts, so every time a tool is picked up, the mesh bed leveling is activated if there is a height map saved.
Gotcha. And did I save one in the process of like when we were leveling it before?
Yes.
Okay. Cool. All right. So then let's just slice this and run it, right?
Yeah.
All right. I probably have
this one is a.
Oh, not that. That's not what I want at all. Probably have to tell it what USB port, or like we have to get the file onto it somehow, right?
You can upload it via the web interface.
Oh, how fancy. So, slice? Let's see how long this is going to take. Doesn't look like there's a height profile
I
here.
think you should throw a look over the general settings of the slicer first, just to make sure.
Right.
Only a short glance.
3 perimeters.
Or at least take a look at the general G code. I'm fine with that.
Let's. Normally I would I'd drop the resolution, or I'd drop the density so we can see. But let's see. So it's 0.2 millimeter layers, 50% first layer height. That seems about right.
Yeah.
18% infill.
Can you show me the
Let's see.
Can you show me the generated file from the start script? Is the most critical. So
Right. So let's see. So we sliced. Probably want to. I probably want to scale this down a bit because it's too. It's going to take too long. It's going to take 2 hours. It's a bit on the slow side. So let's go back here. I'm just gonna scale it. Scale factor. Let's call it 75%. Is that going to make it too small? 50? Is 50 going to be too small? I just want to make sure. Oh yeah, that's fine. As long as it's an integer number of lines. Okay, so this is going to take 20 minutes. That's much more acceptable. All right. So here we go. And I will export the G code and then we'll open it up. I'm just going to save it in my downloads folder. All right, I'm going to export it and open it up, and then we'll wait for that to show up on the stream. Next time, I'm just a little worried about sharing my stream because a little worried it'll take up too much bandwidth. So let's see, downloads. We got our G-code file, and let's open her up. Put this here. And let's make our font big enough that folks can actually friggin' see it. All right. So yeah. Actually, let's try. Let me try sharing my screen. Let me see. Oh, I have to pick which window to share. This is obnoxious. There we go. Resolution, frame rate. All right, so that should you should now be able to see this without the. We should have done this earlier. Should now be able to see this without having to wait around. Let me know if that works. Yeah.
let's see. So scroll further down, please. So no, so the G29 is the mesh bed leveling, and
all
then
right.
T1 it picks one tool, and
Uh-huh.
there is the heating is missing, so we need to set the temperatures before the T1. So if you input some heater commands, like which tool do you print? T1, so you put in G10 P1 and then do an E, and then do an S 230 or the temperature you want to print with.
Probably 210 for PLA, right?
Yes. And if you want to set the standby temperature, it's with the R parameter. And then next line you
Oh, this is the first layer we want to be
for the
hotter.
bed. So,
Okay, pardon?
and I can't. Then the next line you do the heated bed. So what is it? M190 or so. I'm not sure about the
Let's
code
see.
there exactly. M190, M190, and then the temperature for the bed S60.
S60. All right. Shouldn't this be added automatically?
So and yeah, this is the workaround you need to do with the start script in the Prusa slicer or in the super slicer. It's probably not configured in the slicer, so we just picked a blank thing. So it's please delete the M98P brush.g.
Oh, I was
right
just
after the T1.
gonna say.
Yeah.
So do we don't want to run T1 twice, right?
It doesn't matter. If T1 is already picked up,
it'll just ignore it.
It will be ignored.
Gotcha.
So yeah, it looks good. It should print. Scroll to the bottom and check the end code, and then we are good to go.
All right. Let's see. Oh, this is all metadata, right?
Yeah.
Let's see. All right, so this is our top. This is our top layer. Wipe end. What is this relevant?
Yeah. Further.
Nope.
It's wipe. It's
Oh, gotcha. I've never
retraction.
actually looked at the G code of a sliced file. Never really had a reason to.
Where's the end?
I don't know. It's so long. It just keeps going. This is the code that never ends. It's because it's all curved. Let's see. There we go. All right.
The last thing needs to be T minus there. M107. Okay. Drop badge. Drop tool. Drop the tool off. Disable mesh. Yeah. This will work. Okay.
All right.
M0 is turn off all heaters. Yeah.
We're in business. All right.
This will work.
Okay. I like the optimism. So, let's load some filament. Right? That seems like the obvious thing to do. Let's load some filament. So let's go back to our Toolchanger and let's zoom the second. Let's zoom out a little bit so you can see everything going. You can see everything going wrong. I mean, going on. There we go. Let's move this back. All right.
Actually, there's a small problem with the code, if I think about it, because the M mesh bed living is done before the heating. So if you could, you should put the G29 after the heating from the bed.
I see. All right, let's do that. So let's see. We've got our G29S1. All right, so get this out of here. And after heating the bed, there we go. Just like so?
Yeah. Yeah, this looks good. Yeah.
Okay, so here we go. Let's. So it's going to want us to home. All right, so we'll have to home. While this is homing, I'm going to go grab a filament. Let's see what kind of filament do we want to run here. Probably some crappy filament, but not too crappy. Pushing it a little.
Do you print directly on glass?
What do you think? Can we get away with? Oh, there we go. Can we get away with printing on glass?
If it's clean, and if it's good PLA.
It's PLA. I guess we'll find out, right? All right. 1 sec. All right, let's give it a little spritz. Give it some alcohol. Probably want to give this an extra spritz or two because I haven't cleaned it yet. All right. Leave this over here. All right, so let's pick up tool 1, right? Drop the bed.
You don't have to pick up any tools. For the filament. Yes, yeah. Do so. Yeah.
Oh,
sorry.
I guess we could load it while it's still docked, but it would probably be a little awkward. All right, and
you can't drive the motor.
The which?
You can't drive the motor, the extruder, when it's docked.
It's like a safety measure.
You can jog it manually via commands, but not with the buttons.
Gotcha.
The web UI.
All right. So let's then turn this up to 205 should be fine. We'll heat it up and let's get our filament. Let's get our filament going. I guess this is also kind of a test. It's also kind of a test of our filament holders because I think I broke one of them while I was installing. I don't really like this peg and bracket thing. Can you still hear me? All right, awesome.
Yep.
All right. Time to remove our. We got to
the
remove our
problem with
safety
these
net.
holders.
Huh?
Yeah, the problem with these holders is that you have to you have to have the bed out of the way, and in certain positions you can't take the spool off.
That, yeah, I can see that. Seems to be a lot of friction. I hope this doesn't have trouble pulling the filament. Seems to be a bit of friction here. I can see that. I gotta come up with a better filament holder. All right, so
There is already one.
oh, was it made by someone who's currently appearing in this very stream? By any chance?
Maybe.
I see.
And maybe it's on download on its website.
Go ahead and check that out. Okay, so we're heated. Can we? Should we hit load filament? What do you think?
That is for the database. It has nothing to do with actually loading.
Oh, all right. So then let's just, yeah. All right. So let's just extrude, right?
Yeah.
Nothing's happening. At least I don't think anything's happening.
You need to shove it a bit. You need to shove it in a bit, or maybe the Titan needs to grab on the filament.
Let's see. Oh, it popped out. Yeah, there's so much slack. Like I can't tell. Oh! Something's happening. Something's happening. I think the retract is working, but extrude isn't. Still not seeing anything.
You can loosen the bowden on the extruder side, and then shove it directly in.
Give it a little tug. Let's see. Yep, it's definitely not in there. All right. That seems.
What is tool 1? Is it Hemera? I think. Do you hear me?
When I hit extrude,
Yeah.
it is it's retracting.
Yeah. So you need to flip the motor cable.
How did that even happen? Like it's
Or
got
you can
it's got a locking
reverse it
key
in.
on it. How is this possible?
Then it's you loaded the config for the Bowden tools, and the Bowden extruders are mounted reverse, so it's reversing.
Oh.
So you can go to config.g and reverse the direction instantly without plugging anything.
Smart.
And
Yeah.
and tool 1 is what extruder number is tool 1? It's 1, 2, 3, 4. 4. So you need to adjust E4.
All right. All right. So I just shared my
Yeah.
I just shared the new window, so you should be able to see this quickly. Okay.
Yeah.
Is this it?
I can see it. No, further up, please.
Drive direction?
There. These are all the drives.
Gotcha.
Yeah, and P4 is for E1, and you make the 0 to a 1.
All right, so P4.
This one, yeah.
All right, so what we should change the other ones, right? Because none of these are Bowdens.
Then do all the other ones other way around.
So it's
I'm wondering do only the zeros to the P3S1.
Gotcha.
And that's the other way. The other two are probably fine.
Yeah. All right, let's see what happens. Hit save.
You need to copy this command or to reboot it, but you don't want to reboot. So go back in, copy the
Yeah.
command for
This one?
extruder 1. This one, yes, and paste it.
All right. I gotta. When it's blown up this much, you can't.
I did.
I can't see. So here we go. All right. Now it should work. Okay. Fingers crossed. Toes crossed.
Now it should work. Yes.
Every extremity that you have more than one of, cross them. Oh, we got it. We have ignition. It's happening. Let's see. I'm gonna jam this Bowden back in, or this filament guide. All right, let's try to get some filament squirting out. Come on, give me the squirt. I'm hurting for
You need to show
a squirt.
details.
All right, hit extrude again. Oh, it's happening. It's happening. Oh, we got a tiny little doo-doo pile of filament. Can you see it? There you go. We got a tiny little poopy pile of filament. So this should be everything, right? Like we should be ready to print.
Yep.
All right. I'm just
Put the tool back and start the print.
All right. Let's zoom back out so folks can actually see what is happening. And drop our tool. Okay, what do we think? What's going to go wrong? Let's take our guesses. I think it's going to let me think. I think the filament's not going to stick, or it's going to be too far from the basically the z-axis is going to be off, and it's just going to like spread filament all over. I don't think it's going to stick. I think we're going to fail at the first layer. Type your guesses in the chat, and okay, so what do we do? Job, yeah, probably this. That's probably what we want.
In the top right corner is a upload and start button.
Probably. Here, let's put the resolution back. Oh, there we go. Upload and start. And this is going to be in our downloads folder. Voidstar Lab logo, yada yada yada. Let's just make sure we've saved it. Save. All right, open her up. Oh boy. Oh, can't. Nobody can see you.
And you
Selected for printing. All right, it should be going, right?
Hover your mouse over the baby steps.
Over the which?
It's heating and waiting for temperature, I think. The bed needs to heat. And it will do the mesh bed leveling first.
Oh, something went wrong. Something went wrong. I tried to load a tool and it jammed. Yeah, it didn't pick up the tool. Yeah. So we gotta stop. We gotta stop this, right? So what went wrong? It didn't even pick up the tool.
Maybe the same offsets error like on tool 1 like before, the one that you adjusted.
What do you think? Like the you think it's like the wrong coordinates? Let's hit the Google server.